Hi everyone, my name is Rutuja and welcome back to Data2Crunch. So today we are going to work on one new project in which we will try to create one automated Lakeflow declarative pipeline. For this, we are going to utilize Databricks platform. So before jumping onto our project and have hands-on, let's try to understand some of the basics which are required for this project. Let's try to understand what was exactly happening before this Lakeflow declarative pipelines came into scenario. So earlier, building and operating these data pipelines, it used to come up with lots of manual work. For example, this checkpointing. So you had to manually configure these checkpoint paths, and failure to any one of these configurations, it used to cause lots of duplicate or missing data. So these retries were very inconsistent. Then for the daily partition and computation, engineers had to recompute full tables on a daily basis, even if you are changing a very small part in it. So this partition pruning, it was also manual. Then for the dependency management, you needed to manually create job DAGs and the orchestrations. And in this scenario, if you're changing any one of the table, that means that you have risked breaking of the downstream jobs. Then for the late arriving data, that means for the backfill handling, it used to require lots of complex reprocessing or custom backfill jobs. And in this scenario, there was a possibility of schema changes too. And these schema changes often used to break the data pipeline. Then data discovery, that means tracking of the data lineage, it was also manual and very inconsistent. Then quality checks. This data validation was ad hoc, that means it was separate from the pipeline. So in this scenario, what used to happen, this bad data, it often used to slip to the downstream of our data pipeline, and we used to work on this bad data too. Then for the deployment infrastructure, our teams, they needed to set up the clusters, they needed to they needed to tune the Spark configurations. Then they needed to scale up the resources whenever required, and even like monitoring of the jobs, it was also a manual work. Then version control, for this, like notebooks or the scripts, these were like it became very hard to version or share or promote them in between different environments. So because of this, all the manual work, it has increased the operational complexity. Then we started getting production issues. Then it lacked our productivity, and all of our ETL pipeline performance, it became very less flexible. So to overcome all these manual work, Lakeflow declarative pipelines came into scenario. So with Lakeflow declarative pipelines, also known as Lakeflow DLT, you as a data engineer just write the code, and rest of the manual work, Databricks takes care of the same. For example, for checkpointing and retries, Lakeflow, it automatically manages the checkpoints and retries. So in this situation, if any of the job fails, then it will restart from the last checkpoint. And in this way, we will avoid duplication of data. Then for daily partition computation, Lakeflow, it computes only what is new or what has changed. That means that it supports incremental processing. So with this optimized pruning, we get faster pipelines along with the lower cost. Then for the dependency management, Lakeflow, it builds the pipeline DAG automatically from our live table references. And along with this, it also ensures that we will have correct ordering, parallelism, and orchestration too. Then for the backfill handling, Lakeflow handles late arriving of data natively. It also supports schema evolution and automatically backfills our data without the need of any extra jobs. Then data discovery, we have built-in data discovery and lineage tracking through our Unity catalog and DLT UI. With this, it also provides the visibility of which table depends on what table. With this, it also gives quality checks. So declarative, expect, and constraint rules, it enforces data quality in line with our pipeline. Deployment infrastructure, Lakeflow runs on serverless or managed infrastructure. So compute autoscales, and it also compute autoscales, and Databricks handles the orchestrations, retries, and fault tolerance too. Then for the version control, pipelines get defined in either SQL or Python files, and along with that, it has full integration with Git for the CI/CD workflows. Then if we talk about data processing engine, Lakeflow uses Apache Spark along with Photon Photon is nothing but vectorized query engine for our optimized performance. Then it uses Unity Catalog for unified governance. So with this Unity Catalog, we get centralized governance with the benefits of fine-grained access, lineage, auditing, and compliance enforcement. So every table which will get created here, it gets registered in Unity Catalog and it ultimately inherits the governance policies automatically from this Unity Catalog. Then if we talk about optimized storage, our Lakeflow, it is built on the top of Delta Lake, which guarantees ACID transactions, schema evolution, time travel, and so on. So with this, we can say that you as a data engineer, you just declare the logic and the constraints, and Databricks, nothing but Lakeflow DLT, it takes care of all the operational, reliable, performance, and governance aspects in the backend. So that is why it is called as declarative. It means that you just specify what you want, and Databricks declares or decides how to run it very reliably. So this is how this Lakeflow DLT works. So this Databricks Lakeflow from the broader perspective. So as we all know that it's a unified data engineering for the data intelligence platform. So if we talk about how it solves, what it solves and how it works. So we know that historically building pipelines means lots of custom code for ingestion. Then we'll have dependency wiring, checkpointing, and the backfills. Quality checks, those used to live outside the pipeline. Then the governance and lineage was where the manual tasks. So altogether, the result was slow delivery and the brittle operations. Okay. So for this, Lakeflow came into scenario. So it unifies three things. The first one is connect for efficient ingestion. Then we have declarative pipelines, also or previously known as DLT. So this is where we write the code, and then we'll have jobs, nothing but the workflows, where we will schedule our jobs and will perform the orchestration. So all of this all together, it runs on Spark and Photon along with Unity Catalog governance and Delta Lake storage. So if we'll see one by one, first one is connect. So this is nothing but data ingestion layer of our Lakeflow. It provides efficient connectors to pull the data into our Databricks from the multiple sources. So these multiple sources could be anything. It would be files in the cloud storage or the databases or like message queues from the Kafka or APIs or IoT stream. It could be anything. So with this connect or with this efficient data ingestion, it comes with the some of the main features. So the first feature is Autoloader. It is for incremental file ingestion. Then the second feature is that it handles schema evolution, retries, and deduplications automatically. And then the third main feature is it works for both batch and streaming ingestion. Then we have declarative pipelines. This is nothing but transformation and quality layer. This is where you define your pipeline either in Python or SQL. This is where you declare what you want and Lakeflow figures out how to run it. So after declarative for this we have main features too. So the first one is automatic dependency management. So DAGs, those are inferred from the live table references automatically with these DLTs. Then the second one is data quality rules. We can set our data quality rules via expect or constraint over here into DLT. Then it also supports incremental processing with checkpoints and the inbuilt retries. And lastly, it supports slowly changing dimension 1 and 2, and it also helps us with the CDC flows declaratively. Then the third one is jobs, previously known as workflows. We can say that it is nothing but orchestration and scheduling layer. It ensures pipeline and other tasks, those are running reliably and those are on schedule. So the main feature for this would be first is scheduling. So it would be like cron-like or event-driven. Then we will have retries and alerts in case of maybe failure or success. We can set accordingly, and it will trigger emails as a uh, like it will be a kind of alert via email to us. Then we have orchestration. The third feature is it orchestrates pipelines, notebooks, ML models, dashboards, all of these things in one place. So this is how these jobs helps us. So altogether we can say that we will think these all of this as three-layer pipeline system. Okay, so the first connect, it brings raw data into our Databricks efficiently and incrementally. Then declarative pipelines, it will clean, transform, and enrich our data using Python or SQL. And then once we are done with cleaning and transformation or aggregations, then jobs, it will help us to schedule and orchestrate our pipeline, and it ensures that it will run either daily, hourly, or incrementally with retries and monitoring. So this is how this three-layer platform or three-layer pipeline system will help us. So connect, think of this as ingest or ingestion. Declarative pipelines, think of it as like transform or data cleaning, transformation, and ensuring quality. And jobs, think of this as orchestration and delivering the results reliably. So this is our Databricks platform. So if you'll come to jobs and pipeline, we have these options here, which is ingestion pipeline, ETL pipeline, and job. So right now we have just seen that with the Lakeflow we have connect, then DLT, and then workflows, right? So these options are nothing but this ingestion pipeline, ETL pipeline, and jobs. So this is, you can see, so this is, let's say, suppose our third party resource. Okay, then using ingestion pipeline we can connect our third party resource to our Databricks using this platform. This is nothing but our connect platform. Then once we will connect to our third party sources, then we will use DLT, where we will create our pipeline, which is nothing but our DLT pipeline, Lakeflow pipeline. So once we are connected with our third party sources with ingestion pipeline, then we will ingest our data into this ETL pipeline, and then we will perform cleaning or transformation, or we can perform some aggregations too in this ETL pipeline. Once we are done with the creation of this ETL pipeline, then these jobs come into scenario. So with this job, we will schedule our ETL pipeline along with any other task. It would be either maybe BI or ML flow. It would be any other platform or any other task. We will connect these or we will schedule these ETL pipeline using this jobs option, which is nothing but workflows. So if you'll open these, or if you'll click on these options one by one, then ingestion pipeline, we can see that we have, it states that we can get started by connecting to a data source, any third-party data source, or we can upload the files into our local file too. So Databricks connector, we have Salesforce, SAP Cloud, Reports, ServiceNow, Google Analytics, SQL Server. Then to upload the data locally, we have files option, in which we can create or modify the table using our files. Then we can upload our files into volume, or we can create the table using Amazon S3. Then we have Fivetran connectors too. So let's say suppose we will click on this option, and we'll see how many partner connects are available. So in the Databricks marketplace, for the partner connect integration, we have Fivetran, Rivalry, Snowplow, and these many options are present for our partner connection. Okay, so this is how we can connect with our third party sources. And then once you get connected with that, with using this ingestion pipeline, then we will create our pipeline using this ETL pipeline. So once you will click on this ETL pipeline, here you can give the pipeline name, then you can select respective Unity catalog and schema from here. Then you can select the language in which you would like to code, SQL or Python. We have some advanced options too to connect with our it would be either we can start with the empty file, or if we have any existing files, then to use those files we can select this option. So these advanced options we have. So once you will connect with these options, once you will select any one of these options, and then you can create ETL pipeline. Okay, so for example pipelines, I'll show you. We'll see this pipeline. So this is our pipeline. So we can create this pipeline using ETL pipeline option. Okay, and once you will create this ETL pipeline, then to schedule that pipeline, we can use this jobs option. So using jobs option, we can add whatever tasks are there which we would like to schedule, or which we would like to have one after another. And then once we will add these tasks and interconnect them with each other. Then we can schedule or add triggers for the same. Then we can use job parameters. We have tags. Then we can have job notifications also. We can give our email address here. So in this way, we can schedule our jobs and then we can click on run now. So this is how our jobs functions. So let's say suppose if I have any pipeline, then I'll show you. So if you'll see here, in this job section, I have connected my bank pipeline, which is my DLT pipeline, and afterwards I have dashboard too, which is dependent on this pipeline. So I interconnected this dashboard with my ETL pipeline, and then I can click on run now, and then this job will start running. We have scheduling options too. We will see that options afterwards, but this is how this altogether Lakeflow looks like. So it connects or it adds up ingestion pipeline, ETL pipeline, and jobs. Now let's look into Lakeflow Connect option with which we can ingest our data. So we have recently seen our Databricks platform where we have seen how to navigate to jobs and pipeline. Then we have ingestion option. So once you will click on that, it will go to this data ingestion option, which comes under this data engineering. And with these connectors, files and Fivetran connectors, we can connect our Databricks to third-party resources. So once you will get connected to any of the data resource, then we can load that data from those resources to our Databricks, which is nothing but our data ingestion option. So for that, we have three options. First one is create table, copy into, and then the third one is Autoloader. So with these three options, we can fetch our data from the data sources to our Databricks platform. So this we'll see how it works one by one. So let's first see two types of data. So we have two types of processing. One is batch processing and another one is streaming processing. So in this batch processing, data is processed in the chunks at the scheduled intervals. Okay. So those intervals, it would be either hourly, daily, or weekly. For example, like loading yesterday's sales data into our warehouse every morning. So for that, we can use batch processing. So the pros of this batch processing, it is very simple, reliable, and easy to manage. And if we talk about cons of our batch processing, then it is not real time. So there is gonna be always some delay when we work with batch processing. Then we have this streaming processing. So in this streaming processing, data is processed continuously as it arrives. For example, it would be like processing live transactions from the banking system or clickstream data from the website. So for that, we can prefer streaming processing. So the pros would be it is real time, it gives us near real time insights. And if we talk about the cons about the same, then we can say that it has little bit complex setup and the monitoring also. So this is how we can handle batch or streaming ingestion seamlessly in our Databricks. Now let's see how we can ingest our data into Databricks DLT. So the first one is create table. And this is the most straightforward method. In this, we can directly create delta table from the files which are stored into our data lakes. Because of this method is best for static and small data sets. But in this, we need to remember that this is batch and one-time ingestion method. Hence, if your source file changes, then you will need to reload them again. And because of this, we can say that it's not suitable for ongoing or incremental data pipeline. So think of this create table as your quick and simpler way to bring your small reference data into your pipeline. So this is the syntax. So we are using DLT decorator, and then afterwards we are defining one function. The function name is country lookup. So this function name is going to be our table name. So this table name is going to be our country lookup. And in this we are returning the file which are stored into our volume. Okay, so we are using .load and our file name is countries.csv, and this file is stored into our data lake or stored into our volume, and this file we are reading into our table named as country lookup. So this table is going to give us the data which is stored into this countries.csv file. So this is how this syntax looks like, and in this way we can create one table. Now the next one is copy into. So this is our second method, and it gives us incremental ingestion in the batch mode. So with copy into, Databricks keeps the track of files which are already loaded. Hence, it automatically skips the duplicates. Because of this, this makes it great for the situation where we are receiving the recurring data files. But in this, we need to remember that it's still a batch ingestion method, but unlike create table, it can handle ongoing file arrivals. So you just need to schedule or trigger it using Databricks workflows or the pipelines. Hence, we can say that copy into is best when we have periodic new files and we just need to ensure that our data is getting loaded only once without any duplication. Again, we are using DLT decorator and we are declaring one function. Function name is sales data, and this is going to be our table name. Here we are copying our data from this path to this path. So we can say that these files are stored into volume. So this raw cells, we need to copy this raw cells into sales data. So these both the paths we need to give it here, and we are saying that our table would be of type delta, and then our table name is going to be sales data, and afterwards we are just declaring what is our file format of the raw sales files, and then we are giving format option. This is optional. You can just say header true, infer schema true. So these are the options which you can give it here. But in this, we need to focus on how we can copy our data. Okay, so this is the raw sales data which we are copying into a delta table named as sales data. So this is how we can use copy function. Copy into method. Then we have Autoloader. This is the third one and most advanced option. So this is, we can say that, a streaming ingestion method which is built on structured streaming. So Autoloader continuously monitors your data lake for the new files and loads them automatically into your delta tables. Because of this, we can say that it also supports schema evolution. That means that if your source schema changes, then it can automatically adapt it and it will not give you any error at the destination. So this makes Autoloader ideal for real-time data pipelines. Hence, we can say that while this create table and copy into are batch oriented, Autoloader is designed for continuous and scalable streaming ingestion. So this is the syntax. Again, the same, we are using DLT decorator and we are using we are defining one function, and this is going to be our table name. In this, we are returning the files which is stored at this path, which is into volumes. So our file name is transaction, which is into CSV format, and if you'll see, we are using cloud files here. So in the option also, we are saying cloud files.format, cloud files.infer schema. So the format would be cloud files, and here if you see, we are saying read stream.format. So this is the code for Autoloader, where we are returning the file which is stored into our volume with readstream.format, and our format would be cloud files, and then we are declaring options, and then we are loading our data which is stored at particular file path. So this is how this Autoloader method works. Now we begin with Lakeflow Declarative Pipelines, which some of you might know by their old names as Data Live Tables or DLT. So let me explain it very simply. Normally, when we build any data pipeline, so in that case, we face lots of problems. All right. For example, we need to manage the cluster, then we need to schedule the jobs, retry failures, then we need to keep the track of lineage, and also we need to make sure that our data quality is good. So that's a lot of operational overhead. So these Lakeflow declarative pipelines, these are going to remove that complexity. So here, the word declarative is very important. It means that instead of giving instructions step by step, we just declare what we want and Databricks will figure it out rest of the backend work. So for example, think of this as we have gone to the restaurant and we are ordering the food. So you just don't walk into their kitchen to cook your meal, right? You just tell the waiter that I want pizza, and the kitchen staff will take care of everything, right from cooking, seasoning, serving. So similarly, In the Lakeflow, we just say that I want a table to build from this file, or I want this rule to ensure that I'm getting good quality of data, or I just want this table that connected to that table. So Databricks then handles all the orchestration, scaling, retries, and optimizations automatically in the background. So we have some key benefits for the same. The first one is automatic orchestration. So the system knows what to run and in what order. We just don't need to do anything in that. Then we have declarative processing. That means that you just say what you want and not how to do it. Then we have unified batch and streaming. That means that there is no need to build separate pipelines for each one of them. So in one pipeline you can use both batch processing and streaming processing. Then we have built-in data quality. For this, we can use expectations. These expectations acts as a rule to block or drop the bad data. Then we have resiliency and reliability. It means that it can recover from the failures automatically. Then we have governance and lineage. That means you can always trace where your data is coming from. Then lastly, we have productivity boost. That means that less time fixing operations and more time working with the data. So with this, it improves our productivity. So this is some of the basics about Lakeflow declarative pipelines. Now let's move on to our subset, we can say, which is dataset, which is a part of this declarative pipelines. So in Lakeflow pipelines, the main building blocks are these datasets. So dataset is just a table or a view which is managed by DLT. So these datasets are important because they are foundation of our pipeline. Then they can be reused anywhere. So in SQL, for example, if you are using SQL language, then you can call them with live function, or in pipeline, in Python, you can read it using dlt.read function. Then we can say that it also provides governance along with quality by attaching expectations for this. And then we can say that they come with the automatic lineage tracking. So Databricks shows exactly how one dataset depend on the another. So this is how this dataset functions. So first one is streaming table, then we have materialized view, and then we have temporary view. So the streaming table, this is like a CCTV feed of your data. So imagine that you have a camera at your shop entrance, and every time someone enters, the feed updates you in the real time. Similarly, this streaming table updates automatically whenever there are new files or records arrive in our folder or in our path which we have declared. So this is, we can say that this is perfect for a landing layer where like files are dropped continuously in your volume or at your particular path, and from there you are reading your files into this streaming table. So this is where we can use streaming tables. Then we have materialized view. So this is just like a photo album snapshot of your data. So instead of being live like CCTV, it's more like taking a group photo at the end of the day, and it stores the result of a query, and it refreshes when our pipeline runs. Okay. So for example, we could have a query that calculates, let's say suppose total transactions per customer. So that result is stored as a materialized view. So we can use this when if you are running a pipeline, then you can use this into your gold layer, because that's where we can do aggregations, and we have this ready to use table for which we can use for the dashboards. So this is how this materialized view works. Then we have temporary view. So this temporary view is like a rough sketch on your notepad. So it doesn't save permanently. It doesn't save your table into your Databricks. So it's just for intermediate steps or for the debugging. So if you want to test transformation, or if you want to join two datasets temporarily, and then you need to check what is exactly happening. So in that case, you can use temporary view. So to recap it quickly, streaming table is live. It is always updated. Materialized view, it is stored and refreshed snapshot, we can say. And temporary view, it is a scratch pad, we can say, with the no storage. Okay. So moving on to the next slide. So here we can see think we were having one. Okay. So this is the syntax to create streaming table. We'll see here. We are using this DLT decorator, and afterwards we are defining one function with the name landing customers incremental. So whatever we are writing in between this is optional. Even if you don't write it, it is not going to harm anything. So here we are declaring table name. So if you don't give this table name, then whatever we are declaring it here or writing it here with the function name, that is going to be your table name. So once you use this decorator, then we define this function. In that we are returning the files. In this case we are using this streaming table. So for that we are using this dot read stream, and the format of our files would be cloud files. And in the cloud files, we have these files saved into customers folder, and those files are CSV files. This option is optional, header is true. Then we are defining the schema. So earlier we have defined one schema named as customer schema. That schema we are giving it here, and then we are loading our data, and this is the path where we have our files saved. So this is how we can create streaming table named as landing customers incremental. So this is another way to create streaming table. So here what we are doing, we are creating one DLT, we are using this DLT table decorator, and the name of our table would be, streaming table would be bronze customers ingestion cleaned. And here what we are doing, so now we have fetched all of our data from the folder which is into volume, and we have fetched our data into this streaming table named as landing customers incremental. Now, next going forward, as I have fetched all the data into my declarative pipeline, now I need to work on that data. Okay, so for that, let's say suppose I want to clean that data and do some transformations. So for that, what I can do, this is my table, this is my already created table which we have just created it here. And now we are creating another DLT table, another streaming table with the DLT decorator, DLT.table, and that table name would be bronze customers ingestion cleaned, and we are defining the function for the same, in which we are again reading the streaming table which is landing customers incremental. So what we are doing here, we have our file into our volume. We are creating this streaming table, first streaming table, where we are reading the data from the files into this streaming table 1 named as landing customers incremental. And in this syntax, we are creating another streaming table in which we are reading the data from the first streaming table. So this is how we can create the streaming table. So streaming table, remember it, right? DLT.table decorator along with this read stream creates a streaming table. So here we are going to use decorator, this decorator plus, while reading we are going to use a keyword as read stream. So this is altogether creates our streaming table. Now the next one is materialized view. So for the streaming table, what we were doing, we were using DLT table plus read stream, which was equal to streaming table. So for the materialized view, it would be decorator DLT table plus, instead of read stream keyword, we will just use read. So this will create your materialized view. So here we are creating one materialized view named as gold cust account transformation aggregation, and for this we are reading this already created table into this new table, new materialized view named as gold cust aggregation. So this is how we are creating our materialized view on top of our source table. And in this source table would be this one, which is gold cust, whatever it is. So this is how we can create materialized view. Then we have temporary view. So for the streaming view, it was decorator DLT table plus read stream. This was table. For the materialized view, it was decorator table plus only read. And now for the temporary view, it will be a decorator, and instead of table, it will be a view decorator with either read stream or read. So the difference is only this one. Instead of table, we are going to use view. So here we are creating temporary view named as Silver Customer Transformation View. This is the name again, comment. Again, these are optional things. And here we are reading our table, already created table, or we can say source table, which is Silver Customer Transformed. So we are reading this table into our view named as Silver Customers Transformed View. So this is how we can create our temporary view. Now next, going forward, let's check one example for this. So in this, this is our first run. Okay, so we have run our pipeline for the first time. So in this, we can see that we have two streaming tables. So let's say suppose we have two tables. First one is customer table. So let's say we have this customer file and then we have account file into our volume. Okay, and now we are fetching those files into respective streaming tables, and we have created these two streaming tables to read the data from the files. Then we'll see output records is here 1.1k and here 200k. So the first run, for the first run, our file records were 1.1k and 200, and then we have created this whole pipeline in which we have created these streaming tables. Then we have created materialized view, then we have created normal view. So after these, obviously we are doing here data cleaning, data transformation. So these are multiple layers in this pipeline. So we have 1.1k and 200 records on which we are doing some kind of processing. And now in this materialized view, we were having 497 entries. Here we were having 10k entries. Here we were having 108. So in this way, we have different numbers or different numbers of entries into our respective tables based on that particular step in which we have done cleaning on transformation. Okay. So after this first run, we have ran our pipeline for the second time. Okay. So in this while running this second pipeline, I have changed these files, or I have updated these files, and now I have new entries. For the accounts, I have 1.3k entries, and for the customers, I have 200 entries. So in the next run, if you'll see, streaming table is reading only new records, and those were 1.3 and 200. Okay, and now again, whatever processes we are doing here, cleaning, transformation, aggregation, whatever it is, so in those, these streaming tables are just reading new records and not the records which we have already processed in the first run. But we will see in case of materialized view, we'll see this option, we'll see this written as incremental, and in this, we'll see it has added the records. So earlier, let's say suppose in this case we were having 497 records, and after the second run, whatever the records it has processed, let's say X records, so those X records were added into this, and it has given us all the records as 1.1k. So this is the difference between streaming table and materialized view. So materialized view, it just keeps adding all the records in one table, okay, in one these table. But instead, in the streaming table, it is just not reprocessing all the old records. It has just taken the new records and it is just processing the new records. But instead, materialized view, it just keeps adding old records on the new records. So this is the main difference between streaming table and the materialized view. Now the next part is expectations, and these expectations are nothing but our quality rules. So these are completely optional, but these are very powerful, and we usually attach these expectations along with our dataset, and every record flowing through this gets checked against it. Okay. So in SQL, when we create our table, then what we do, let's say create table, and particular table we will have, and then we will define particular column with those respective data types, and along with that we will add constraint too. Okay. So let's say suppose customer ID, then I would like to have a constraint as primary key or not null. So these kinds of constraints, those are nothing but our expectations in our DLT. So for this, Let's say suppose this is our raw data. Okay, we have one volume, and in that volume we have CSV file, and that is nothing but our raw data. Now on this raw data we will apply our expectations. Okay, so file, let's say file has two columns, ID and name. So this ID, let's say 1 2, and then maybe blank blank, and then I'll have 5 and respective names. Okay, so we are going to set certain expectations here. Let's say suppose I'll apply constraint or expectation as ID. I don't want it to be null, it should have any value. Okay, so let's say first and second record gets passed through it, then it will check if it has ID or not. Let's say it has ID, then our expectation is passed, then it will keep those records. So ID 1 and 2, these records will be kept. Okay, now it has came to third record, and it will, if it will check it here, we can see that we have ID is equal to null. That means that our expectation has failed. Now our expectation has failed, then we need to take certain kind of action. So in DLT we have three kinds of action. One is warn, then drop, and then the fail flow. Okay, for example, I'm working on this same dataset, and I'm fine with IDs, ID is being equal to null. I want those record for certain condition, and I want to perform certain aggregations on the same. So in that case, what I'll do, I'll use warn, warn action. So with this, what will happen? DLT will just inform me, or it will just warn me that okay, whatever you are processing, you have certain null records. So in this case, it will say, okay, you have two null records. I'm just warning you, and we are processing, or we are having data with the null values. So we are going to process on the same. So it will just warn me. Okay. Then I have certain condition, and in that I need to completely skip my null values. I completely don't want it to for the further procedure or further transformations. Then in that case, what I'll do, I'll just use drop. So if when I'll use drop condition, then it will simply drop these two records, and I'll get the values only for 1 2 and 5. So with this I got 1 2 blank records and 5 2. With this I'll get only 1 2 and 5. And the last condition is fail flow. So in certain critical situations, if I have null values, then I need to completely stop my further process. It would be anything cleaning or transformation. So in that case, I'll just say fail flow. So when our data will pass through this, and when it will check that you have null records, it will fail our pipeline here, and it is not going to give you any output. It will simply throw you one error. Then you will need to check that error and need to act on that accordingly. So this is how our expectations work. Now coming to next slide. So let's say suppose in the last part we have applied only one expectation, right? For the customer ID is not equal to null. Now in the next situation, what we are doing, let's say suppose I have a big table, I have 15 to 20 columns in that, and I need to apply constraints on many of the columns. Let's say I need to apply constraints on my 5 of the columns. Okay, so in that situation, what we can do, we can create one expectation group, and in that expectation group I'll define all my 5 rules over there, and then I'll pass all those rules while creating the table. So let's say suppose this is my data, and we have here three expectations where we are checking if the count is equal to 0, page ID should not be null, and title should not be null. Okay, so now everything is passed. So now what will happen, our raw data is going to check all these rules. Okay, so these rules I have defined, and then I'm going to read my all the data. Now we have came here, it will ask all pass when we are passing through these expectations. If I have all the data, and all the data has been passed through these expectation, we will simply pass it, and we are going to keep all the records. Okay, in this case we have three columns, ID, sorry, maybe count, and then we have this page ID and this title. I have first record with all the values. That means that my record has passed through these expectations, then I'm going to keep that record. Okay. Now let's say suppose I have second entry in that maybe count is -1 and page ID, okay, it's 2 and title is something XYZ. So in this situation, my one expectation has failed, which is count not greater than 0. So in that, my record has been failed. And again, I'm depending on the situation and depending on the business requirement, I'll take the action whether I need to warn, whether I need to drop that records, or whether I need to fail the pipeline and don't need to process it forward. So once our pipeline will get failed, it is not going to process anything further. But in case of drop, we are going to process forward. So in case of drop, it will simply drop this record, and the rest of the records will get move forward, and it will continue with the processing. When all of the records are passed, then in that case too, we are going to continue with the processing. In the warn situation, we are going to continue with the processing with the warning, and in that case, I need to remember that I'm going to process the data which is a bad data. So this data is not good for the business, but for the certain situation, I'm going forward with that. So in this way, we can continue with the processing, and with the fail flow, we are not we our pipeline gets failed and we don't move forward. So again, here is the summary. We have 3 actions: warn, drop, and fail. And there is one more thing. If you'll not give any kind of action there, then by default it will be a warning. Okay. So in this situation, SQL syntax would be expect, and Python syntax would be dlt.expect, or you can have dlt.expect all 2. So in this, invalid records are returned to the target. Then we have drop. So syntax is again same, dlt.express or drop. This will be the addition situation. And with the SQL, I'll have expect, then the condition, and then on violation, drop row. So this is the syntax for the action drop. In this, invalid records are dropped before data is returned to the target, and the count of dropped records will be logged alongside the other dataset matrices. Then I have failed. SQL syntax would be expect, then I'll give the condition, and then on violation fail update. So here it was drop, now here it is fail. Again, for the Python syntax, instead of drop, I just need to write fail. And in this, the result would be invalid records prevent the update from succeeding. So the manual intervention is required before reprocessing, and this expectation causes a failure of a single flow and does not cause any other flows in your pipeline to flow. So that particular pipeline, let's say suppose I have applied I have two tables. This is X and Y, and I have applied constant on the same, and I have applied fail constant here, and one of the record was failed. So this pipeline will not move forward, but this table, and if this table has passed all the conditions, then this table is going to pass forward for the processings. So this is how this fail action works. So this is the syntax. As I have told you, we need to use it while creating a table. So if you see here, we are creating one table named as bronze customers ingestion clean. And as we have seen it previously, how we can create streaming table. So this is the same situation. It's just that this is the DLT table decorator, and then this is the function, and the middle of this, we need to declare our constraints or expectations. So this is also okay to write it, but this is not the good practice to write all the constraints one by one. So if you have, let's say suppose I have only one constraint, which is customer ID, or let's say suppose for name, then these two constraints I can declare it here. But if I have more constraint, this one is okay. I'll not say that this is not going to work. This is also going to work. But for the good practice, what we can do, we can we can have our quality rules book here. In this, we will display all the quality rules which we have written here, and then we will call these quality rules over here just before writing the function. So this is also this is the good way or best way to write the expectations. So this is how we write the expectation in the middle of DLT table and that respective function. And we need to remember that these expectations are declarative, okay? You don't need to write any complicated code for this. You just need to define these rules, and rest of the things, Databricks will take care of that. So this is how these expectations work, and these expectations can be defined on any data set. It could be either streaming tables or materialized view or temporary view. So we can use it with anything, and they are built directly into dataset definition, which makes them easier to manage. So this is our dataset definition, and we are using it with that. Because of this, it becomes very easier to manage. Okay, so this is how these expectations or quality checks function. If we'll see here now, this is the output of our expectation. Okay, so whatever expectations we have set here, right, for our clean table. So this once I'll run this, then this is gonna be the output. So for this, what I'll do, I just need to select that respective table name. Sorry, for that respective table name, if you will come here under the expectations, we'll get, okay, we have 13 expectations. Out of that, 7 has been met and 6 has not been met. Okay. So once you will click on this, it will open this section. In this, we can see that we are seeing all, and we have option to check only failed expectation. But if we'll see all, then it will say, right, okay, so for this column we have applied expectation with the action drop. Then for this we have allow, that means we have just bound it here, and for the customer ID we have applied the action of failed. So it states that, okay, for this constraint you have 51 records failed, for this 40, for this you don't have anything failed, for this also you don't have anything failed. So for this drop, whatever records has been failed, those records are going to be dropped for the further process. For the allow, if you would have here 5 records failed, then also it would have been allowed to process it forward. And for the fail, our pipeline would have failed and you would not have gotten this output, and it would have simply thrown one error, and then data engineer need to check the error and then need to act on that accordingly. So this is how the output of our expectations will be. Let's try to understand the next concept, which is flows. So Lakeflow pipelines use these flows basically to move the data, okay? And each flow is made up of a query along with its target. So the query says what the transformations we need to apply, and then the target says where to store the result, okay? And these flows we can run either in batch mode or also in streaming mode. So we have two types of flows. One is append flow, and then the next one is auto CDC. So the append flow, in the append flow, what we can do, this append flow takes the data from the multiple data sets and it appends them into one combined target. So let's say suppose I have this dataset 1, then this dataset 2, then 3. Then this then this append flow will append all these tables into one new table, in which it will append all the data which we were having into these 3 tables. So this is how this append flow works. Then the next is auto CDC. So previously it was known as apply changes, but now Databricks has changed apply changes with the auto CDC. Auto CDC is nothing but change data capture. It stands for change data capture, and it automatically handles slowly changing dimensions. So as of now, till that, DLT supports SCD type 1 and type 2. So these slowly changing dimensions we can apply using this auto CDC. Going forward, this is the syntax for for append flow. Here we'll see we are creating one new table, and these are previously existed table which we are reading, and then we are appending it into one new table. So this is what we are doing it here. This is our new table, customers US. In this we have already existing 2 tables. One is West and another one is East. So these tables, 2 tables, we are appending into one table named as customers US. So the syntax is very simple. We are using append flow syntax twice because we have 2 tables. For the both append flow, we are giving target as customers US, which will be the new table which is customers US, and in that we are reading our streaming table west and then the east. So we are first reading west table and then we are reading east table, and these two are streaming tables which we can identify because we are using read stream. So this is how we can use append flow and create new streaming table as customers US. Now, so with the append flow, we have one more concept which comes along, which is backfilling. So backfilling simply means processing the historical data that already exists. Okay. So it's just not the new data that arrives today, but along with this, we need to process the historical data too. So imagine that you set up one pipeline for the month of March. Okay. So this is the pipeline for the month of March. But now you also have the files from the January and February. So if you only run the pipeline normally, then it may pick the data which is March or March onwards. This is where this backfilling concepts comes in. So backfilling concept tells this pipeline that go back and process the older months too, because we have gotten this data just now. So this, after applying backfilling, then this pipeline will go back and it will process this historical data from the month of January and February. So this is how this backfilling concept works. So sometimes what will happen, like someone will the question which we will get is like, when do we need to use this backfill and why do we need to use it? Okay. So the first situation would be first load. So in this situation, what will happen when we build a new pipeline and when we want the tables to include our past month's data too, then in this situation we need to use backfill. The same concept which I have just explained it to you for the month of March, January and February. So this is where you can use backfilling. Then the next situation would be your pipeline has done, you have done some logical changes into your pipeline. So this would be required to improve your transformation, or maybe you need to fix any one of the bug. Then once you change that logic, then you need to process all the historical data along with current data with this new logic. So for that also you can use backfilling. Then the next situation would be late arriving data. So let's say suppose source system gets delayed and we get the files afterwards. So let's say suppose I'm processing today's files and I got my delayed files from the earlier week. So in that situation, in that late arriving, we need to use this backfilling. So these are some certain situations in which we need to use this concept. But let's see how does it work with DLT or the Lakeflow, right? This backfilling concept. So as we know that our DLT pipeline, it always keeps our checkpoints. So with these checkpoints, we will know that what files or what offsets those were processed. So that information we will get it through checkpoints. Then for the backfill, we rerun the pipeline over a defined historical range or the reset state. Okay. So for this, let's prefer this code. So in here for the backfill, we need to rerun our pipeline with the defined historical range or reset state. So this is our defined historical range. If you'll see here, we are defining certain years as backfill years. Those are 22, 23 and 24. And then we are using we are defining this one function for the backfill in which we are using append flow. This append flow is going to run on the particular year. Okay. So these year will be 22, 3 and 4. So for that we are going to append the flow, and within this decorator append flow we are defining one more function for the backfill. So with this programming or with this code, we can backfill our historical data from the year 22, 3 and 4. Okay. So this historical data we have processed, and then we often need to control the scope with the filters so that we don't read the unnecessary years. Okay. So right now, as of now, our 22, 3 and 4 data has been processed. Now we are left with the 25 years data. Okay. So now here we are applying one filter. We can say that which is option modified after, and then we are particularly displaying one date, that means 12/31/24. That means that starting from the year of 2025, then that data would be our current data, and that current data would be appended with this logic. Here also we are using append flow, and then we are reading our stream using this function named as ingest. So this is how we can program our backfilling, or this is how we can code our backfilling concept, with which we can process our historical data, and then the rest of the data we can, current data we can process with this logic. But this modified after, this option is very this option is important for this backfilling of historical data. So this is how this concept works. This is the syntax for apply changes. For auto CDC and apply changes, syntax is same. It's just that instead of apply changes, you just need to use auto CDC. So let's first see apply changes. So in this situation, what we are doing, we are creating one streaming table named as transformed SCD1, and then we are going to use this streaming table as our target table, and this is our source table. So this streaming source table we are going to use, and then the target table, based on the streaming source table, our target table is going to be updated. Okay, then we are using the keys. So usually these keys will be unique identifiers for our record. So in this situation, customer ID is the unique identifier of our table, so we are going to use that. So these keys, it will use this key to match the rows between our source and the target. Then we have sequence by. This option we use, this is optional, but we use it often, and it will be used when multiple updates can happen for the same key. So usually we prefer date columns for this. So in this situation, transformation date, this date column, we are preferring to use it here for the sequence by. Then we are saying stored as SCD type. Here we need to define, we need to give, we need to tell which SCD we would like to use. Either it would be 1 or 2. So that we need to add it here. And then we have except column list. So with this, the output which we will get in this SCD1, that output table will not have the columns which we will define or which we will add in this list. So as of now, our SCD1 table will not have transformation date column. So if we'll add more columns into this, 2, 3, 4, whichever columns we will add, those columns won't be there into our new table. So this is how this apply changes functions. The next one is auto CDC flow. As I have told you, syntax is simple. We just need to have create auto CDC. Again, the new streaming table which we defined, we are going to add it as a target. This is going to be our source table with which our target table is going to be updated. Now here our primary key is going to be our transaction ID. This will be our unique identifier. And the sequence by column, we are going to use date column, which is account transformation date. So that one we will use for sequence by. And then stored as SCD type. Here we can define 1 or 2. Right now for this example, we are preferring SCD type 2. So that we are giving it here. Then we have track history column list. So earlier we have added except column list, right? For this we have given except column list. So instead of that, we can also give track history column list. So this will add these columns which we are defining it here into our target table. And then we are having ignore null updates. That means that if the record has null, then it will not overwrite the existing non-null value. So for that, we have this option, ignore null updates. And then we can give our flow name as whichever which we would like to give it here. So here we are giving our name as tags SCD to flow. So this is how we can use auto CDC for SCD type 1 and 2. So this is the syntax which we are going to use in our project. Then let's understand how this SCD1 and SCD2 functions. So with SCD1, we'll see here, this is the before and this is the after update. Okay, so we were having this record with the customer ID 101, status active, name and city. Then I got the new file in which I was having the same customer ID, but the current city of that customer was changed from London to Manchester. Maybe that person has moved from London to Manchester. Then I have gotten this updated record. So with a CD type 1, what it will do after update, it will just remove this record, it will just remove this city name London, and it will add it as Manchester. So in this situation, it will not keep any history of that person stating that okay, the earlier that person used to live in London, now he is living in Manchester. So with SCD type 1, you will not have any history preserved here. So in this situation, whatever the new value you will have, you need to process, you need to move ahead with that. So old value will get simply replaced by the new one. So this is very simple and fast, but it will not keep any kind of historical values. So for if you would like to have that historical data for further procedures, then SCD type 1 won't be helpful for you over here. Then we have SCD type 2, in which history gets preserved. Same situation, customer 101 John Doe, he has moved from London to Manchester. Now with SCD1, it had just replaced this London with Manchester. But now with SCD type 2, in the new table, what it will do, it will add these three columns: start at, end at, and is current. And then along with the addition of these three columns, it will modify the old record with the end date, okay, and it will add the new record. So London, on which date that person has moved out, so that date or the date when this data got updated, or this file got updated, that end date, or when this pipeline was processed with the new updated record, that end date, that will get updated here. Okay, and now this record is inactive, that's why is current option will be false, and then it has added new record with new current city Manchester, and this flag will be true, and start date, it will be given this date as a start date, and end date will be null because this data is right now active and that person is living in Manchester. So this is how this slowly changing dimension 2 functions. The next concept is sync. So sync is nothing but your final stop of the pipeline. So this is where your processed data would land. It could be either delta table or materialized view or even an external system too. So let's say suppose I have created one pipeline and then I have created one dashboard, and that BI dashboard depends on the data which is coming from this pipeline. So in this situation now, my BI dashboard, it would be my sync. So this is how this sync function works. So in this case, let's say we have created one table named as transaction transformed, and this function, we are defining this function with this table name transformed, and on this data set, or in this table, we are fetching or we are reading the streaming data set which is coming from this table, which is transaction ingestion cleaned. So once we are getting that cleaned, we are getting that data from this cleaned table. Let's say suppose we are going to perform some transformations, and once those transformations are done, we are going to store that data into this transform table, and this is my all the transformation logic. So this logic is right now, as of now, not important, but in this case this clean table, it would be my source, and this transaction transformed, where I'm going to have my transform data, this is going to be my sync. So this is how this sync functionality works, and this would be this is the snapshot of our DLT pipeline. Now let's see it. Okay, so this is my Databricks platform. If I'll come to jobs and pipeline, we can create our DLT pipeline with this ETL pipeline. So once I'll select it, then we can create new pipeline here. We can give the name, we can select our catalog, and then schema, and then we can select our particular language with which we can code and create our DLT pipeline. So as of now, I'll just open the pipeline which I already have. So this is my pipeline. So this would be my flow of the pipeline. These are some pipeline details with pipeline ID type, who is the creator, owner, then what's the running status. At the bottom, I can see all the tables which got created by running this pipeline. And then this is the performance of my pipeline. Let's say suppose I would like to open this pipeline and would like to edit it. Okay, so I can click on this edit pipeline. So this is where I have created my pipeline. So if you see here, I'll just minimize this. So we have left navigation bar, then we have this middle panel. So this left panel is nothing but our pipeline asset. So we can say that it is a pipeline asset. At the top, we can see that this is my pipeline name. In our case, it is, in this case, it is bank pipeline 2. Then under it, we have these pipeline configuration. Sorry, folders. We have these folders and scripts. So we have one exploration folder where we can have our test notebooks and ad hoc queries. Then we have this transformations folder. So this is the main folder which holds the complete logic of this pipeline. So whatever I'm going to create, so let's say suppose I have created these Python files under this transformation. So when we are running this pipeline, whatever logic we have written in these pipelines, which comes under this transformations folder, this logic is going to run, and this logic is going to create this pipeline. So that is why transformation folder is important. If you'd like to change this, then we have this settings option. So right now, our source code, as I have said, that whatever we are writing under transformation, that is going to run, because under the code assets, I have given root folder is this folder, and under root folder I have source code with under this transformations. That is why whatever I am going to write under transformations, that is going to run when we are running our pipeline. So we have config paths option also, and we can change this path if required. So this comes under settings section. Then if you see, we have this unique pipeline ID under settings, then pipeline type, what kind of pipeline is name. This is editable. Pipeline mode, what's the pipeline mode. This is either whether it is triggered or continuous. We can change if we want from here. Then creator, owner, we have code assets, which I have told you right now. Then we have default location and assets. So this would be our catalog and schema, under which our tables are going to be saved or created, which tables we are going to create by using this logic. Okay, so streaming tables, materialized view, whatever it is, we are going to get it under this catalog, and then under this we have this schema. Under that we are going to get those tables. Then we have this compute option. By default it is serverless. Then we have pipeline environment. We can change or add the pipeline environments accordingly. We have configurations. If you are declaring any kind of parameter, then you can add that parameter under this configuration section. And then add notifications. So for this, you can add your email address, and then you can save whenever you would like to have notifications when we run the pipeline. It would be either after the success, failure, fatal failure, anything. So that changes or that configurations you can do under the notifications. We have some advanced settings too, where we can check event logs and everything. So this is how this settings section work. So we have seen this left sidebar. Now this middle panel, right? This middle panel is nothing but our code editor. This is where we write the code. And this is where we can have multiple files open, and accordingly we can select that multiple file, and we can write that particular logic in that multiple files. Okay, so usually I prefer, instead of writing each and everything under the one Python file, I usually prefer to have different Python files for my understanding. Okay, so let's say suppose if I would like to fetch the data from any volume to my pipeline, then maybe I'll give the name as landing layer. Then if you'd like to have some data cleaning transformation, or if I would like to have bronze layer from the medallion architecture in which I'm doing data cleaning, then for that I'll have separate Python file. Then for aggregations I'll have separate. Then for transformations I'll have separate file. So this is how I prefer to have separate files for the different logics. Okay. Then we have these utilities. So these utilities are nothing but our helper functions. And then we have readme.md. This is where our document we will get our documentation file to describe the project. So this is the left navigation bar. Then this is the code editor where we write all of our code, whether it would be creating streaming table, materialized view, normal views, temporary views. If you would like to add quality checks, then you can add it over here. If you'd like to perform any kind of data cleaning or transformation, that logic you can write in the code editor by opening that respective Python file. Then we have right hand panel, which is nothing but our pipeline graph. So this graph is the lineage view of our pipeline. Okay, so this is where we can see what is the flow of our data and exactly which table has been created after which table. Okay, so if you'll see, this is our pipeline graph. You need to click on this, then that pipeline graph will get open. If you'll select this maximized option, then you will get the complete outline of your flow. Here we can see that we have created this table, these table, then with this we can see that we have cleaned this data, then after this data we have created this new streaming table as transformed. With this transform table we have created two different tables as streaming table, materialized view, then view. So this is the lineage which we can see. Now we have this bottom panel where we can see all the tables and respective performances. We'll see here, let's say suppose I have selected any particular table, then it will display the data which that table holds here. Then if we'll select on the columns, then it will display all the columns along with their respective data types. Then in the table matrices, it will display your catalog, under catalog, in which schema you have this table, what's the type of your table, whether it is streaming, materialized, what was the duration of execution of that table, then what are the output records of that table. As of now it is 2.4. Then absurd, then if you have any expectations, then that expectations will get displayed here. In that expectations, as we know that we have these actions, dropped, warning, failed, deleted, that will get displayed here. So let's say suppose we'll see here for this table named as bronze accounts transaction ingestion clean, we can see this option, right, where we can see 424 entries. So it displays that dropped records, and it has dropped 424 records. Here if you'll see, it has also dropped 166 records. Output records now we have our 2K. Then let's just check the table matrices for the same. If we'll see here, as for the landing accounts, we were not having any expectations. For this, we have set expectations. So those will get displayed here. So expectations, then with these expectations, it states that we have dropped 424 records. If we'll click on this, it shows we have these three expectations for the channel, type, and amount. And with this, okay, it is showing these failures only, but if you click on all, then it will display all those expectations rules set for that particular column, and which action which we have set for this, and how many records got failed and how many records we have dropped. So this is in the flow we can see some information of ID, type, status. So this is how we can see the expectations which we have set and how it is giving us the result. Then performance, then this one is our materialized view. If we'll see table matrices, then we can see the type as materialized view. We'll see here the symbol for each one of them is also different. So for the streaming, if we'll see, the syntax is a little bit different. So it's kind of like this syntax. So this syntax is like table, and it is giving this type of symbol for the streaming table. If we'll see for the materialized, it has this table and it is giving this symbol for the materialized view. And for the temporary view, if we'll see, we have this table and it is giving us glasses symbol over here. So this is how also we can identify what type exactly it is, whether it is streaming, materialized, or temporary view. Then incremental, if we'll see incrementalization for the materialized view, it is stating that it is full recompute is there for the materialized view. So for the streaming table, we don't have incrementalization. So this is how we can check all the tables from here. Altogether also it gives the same information over here. So to have the overview of all the tables in one go, you can have or you can check it over here. So if you see here, this account transformed SCD to SCD2 table, this table we have used slowly changing dimension 2. Then for that it is creating these two new tables new columns, which is start at and end at. And when we reran the table, some of the entries got upserted. Okay, some of the entries got changed, and because of that, or that information we need to save, or we need to have into our slowly changing dimensions newly created table. So for that, it shows upserted records for these two tables where we have applied this SCD type 1 and 2. So for that, this column we have information for these columns as for SCD type 2, we have 657 records upserted, and for 1, we have 220 records upserted. So this is how this DLT pipeline or that screen functions. It will come here, then this is our pipeline. All files we will get here, all the pipelines will get displayed here. This is our current pipeline. If we'll come here, then it shows the catalog which we have referred here. This one catalog we have referred here. In this is the schema which we have used, and under this, after running this pipeline, whatever streaming tables or materialized view which we have created, those will get displayed here. So if we'll open any one of that, then it will display all the column along with their data types over here. So this is how you can navigate. Then okay, so now we have these two options here. Okay, if we'll click on run pipeline, so let's say suppose now we have run this pipeline, right, for these 2.4 and 400 records. So if we'll run this pipeline again, then it is not going to process this data again. So instead it will check if we have any new files in our folder which we are referring here. So if we have any new values, then those new values will get processed here. Let's say suppose I have added new file with let's say suppose for this table I have 100 records and for this table I have 50 records. So once you will click on this run pipeline, it is going to take only these new records which are 150, and then it is going to process on these records over here. So instead of this run pipeline, if you have the one more option here, run pipeline with full table refresh. So if you'll use this option, then in that case what will happen? So along with this 2.4 and 400 record, and we have added new file for 150 records, right? So this, when we will prefer this full table refresh option, it is going to process 2.4k records plus those 100 new records. Here also 400 records plus those new 50 records. So this is how this full table refresh is going to function, where it is going to read old data too and new data too, because we are having full table refresh over here. Then we have dry run option here. So dry run means it is not going to create any kind of table, but we can get if we are getting any syntax error here. Okay, so I usually prefer this dry run table when I would like to check if I'm having any kind of syntax or not. So let's say suppose I'm using this landing layer file and I'm creating this delta table DLT table. Okay, I have just added this syntax to create this new table which is incremental. Then in this case what I'll do, I don't want to create this landing customers incremental table right now. Instead I just want to check if I am having any error or not. So for that I prefer dry run, so that it will run. If it runs successfully, then I'm going to know that when I'm going to have this run pipeline, then it is going to create this new table landing customers incremental without any error. So for that sake I prefer, or we prefer, using this dry run option. Then we have this schedule option. We'll click on add schedule. Then we can see that you can give your job name, which is our pipeline name. We have simple option and advanced option. Here we can say that when you would like to schedule once in a day or two, every 1 day or every 2 day or every 5 days you would like to schedule it, and then you can select this performance optimized option. You can set the notifications by adding your email address over here too. Then for the advanced option, here after for this advanced option you will get at which particular time you would like to schedule it and what would be the time zone. So these two things that will get added in this advanced option. So every 1 day, 2 day, 3 day, at what time, let's say suppose at 16:35 p.m. I would like to run my pipeline, and you need to specify that in which time zone you are right now working. So if I am in UTC time zone, then I need to I need to add that particular time zone here, and then we can schedule my pipeline. Now next section is of workflows. So these were previously called as jobs, and these are nothing but Databricks built-in orchestrator. So they run and coordinate the tasks, like it may be either DLT pipeline or the notebooks, SQL queries, or BI dashboards. So it could be any task, and these tasks will be run and coordinated with these workflows. So think of these workflows as a control tower that decides when, then on what compute, and in what order each step would run. Okay. So if we say that why we use these workflows along with DLT, right? So with DLT, we can create multiple streaming tables, materialized views or views. In that we can also follow medallion architecture, and then we can create our pipeline. So once we create that pipeline, then with these workflows, we can control when we can run this pipeline, then how failures will be retrieved, and then how outputs will be triggered to the downstream steps, like maybe it would be either DBT models or ML scoring, or it may be BI dashboard. So for this, workflows gives us scheduling, event triggers, retries, alerts, and the permission around our DLT pipeline. So there are some core building blocks for this. So the first one is task. So these are the tasks. So this task means units of work inside a job. So it could be any task, like pipeline task which runs DLT pipeline, or it could be notebook task which runs with PySpark, or it would be SQL task. It could be any table, DLT maintenance table or REST maintenance table. So this would be our tasks, and each task chooses compute. It would be serverless or job cluster. Then it helps us with the retries, timeout, libraries, parameters, and also with the task level environment variables. So the next core building block is control flow, or DAG. DAG means directed acyclic graph. So with this, it draws the dependency in between tasks. So either, like for example, task B depends on task A. Let's say suppose this is B task, A task, C, D, E, F. So these control flow will give us the dependencies, like task B depends on A, then C depends on B, D depends on both B and E. So such kind of control flow, it will be given with the workflow. And with this, it supports both fan out and fan in. So fan out means one task and it will have multiple children. So this fan out means one task and then it will have multiple children, and fan in means many parents and one child. So fan in concept will be applied here, many parents and one child. So it supports both fan out and fan in. And also we can add conditional execution with run if and success failure branches. So that benefit also we will get with the control flow. Then we have triggers. We have schedule trigger. So it would be like cron or interval. So we can say that after every 15 minutes or nightly at 1 a.m. we can run our pipeline. So that comes under schedule trigger. Then we have continuous triggers. So this runs a task continuously. It is good for the streaming monitoring, we can say, or for long running services. Then we have file arrivals. So file arrivals, it starts when files land into your cloud path. Okay, we can say that it is great for autoloader or batch drops. So let's say suppose you have volume and you have certain files and those files are processed. Then afterwards you upload one more file in this volume. Then once this file will get arrived in this folder, which will be under our cloud path, Then once this file arrival trigger can work, and it will trigger our pipeline, and then we will get the output accordingly. And then we have one more trigger, which is table update. So it will start when delta table changes. Okay, it would be any table, and if that respective table changes, then this trigger will get triggered, and we can apply this table updates trigger for the same. Then the next core building block would be this compute. So this is serverless compute. It is always recommended whenever available, and it has no cluster management. Along with this, it is fast to start, it auto scales, and along with this, it secures the isolation. Apart from this, we have two more core blocks. One is second last is reliability. So with this reliability, we have automatic retries under this reliability, with which we can apply this automatic retries at the task level, and you can set the retry count plus backoff for the same. Then timeouts, we have timeouts under this reliability, which prevents the runaway tasks. And then it also has the feature of run if on failures. Okay, so for example, notification or cleanup that would get performed under this reliability. And then the last one is notifications or permissions, and then lineage. So we can trigger emails in the form of alerts whenever our pipeline gets success or failure or partial failure. So we can decide it accordingly as per the business requirement, and we can set the alerts by giving email address at that point or in the workflows. Then we have access control lists at the job level, and along with that, Unity catalog, which we use, it governs the tables with the job touches. So this is the another benefit which comes under this. And then last one is DLT pushes the lineage and quality matrices automatically to the UI. So this is the third advantage which comes under this last building block, which is the core block of this workflow orchestration. So now we will see this workflow orchestration on our Databricks platform. So we are on our Databricks free edition platform. So if you'll come under this jobs and pipeline, you will have these three options, and this is the option named as job, which we are going to use to orchestrate our pipeline or the notebooks. So these are nothing but our workflows. So once you will click on this job, then you can give your job name here. Then you can add your tasks here. It would be pipeline or dashboard or any another task type. So those task type would be notebook, Python script, SQL query, file, SQL alert. Then we have ingestion and transformation, ingestion pipeline, ETL pipeline. We have DBT. For the advanced, we have run job. If we have if else condition for each loop, Python wheel, jar, clean room, notebook. Then for the dashboards, we can use legacy dashboard, or we can connect it to the Power BI app. And these dashboards, these are the inbuilt published Databricks dashboards. So any one of these tasks you can add. So right now, let's say suppose I'll give this name, and then maybe I would like to add a pipeline. So this pipeline has no name. Then you can give that respective name here. It would be anything. Then you need to select that respective type here. Okay, so our type is pipeline, which is already selected. So we will keep it as it is. Then pipeline, you need to select which pipeline you would like to schedule for the workflows. So let's say suppose I would like to have this pipeline to be scheduled. Then we have this option trigger a full refresh on the pipeline. So if you would like to have full refresh on your pipeline, then you just select this, and then when you will run the pipeline, your all tables will get refreshed fully. Then we have notifications option. You can say add notification. You can select the destination. It would be email address. Then you can add your email address here. Then supported destination email addresses, it would be either email, then Microsoft Teams, PagerDuty, Slack, or the webhook. Then you need to decide like on which notifications you would like to have, like once your pipeline will get started, or once it gets success, or once it gets failed, or if you get any warning, or if you have any streaming backlog. Then accordingly you need to select those respective types for which you would like to trigger your email. Okay, and then you have these mute notification options. cancelled runs, then until the last retry. So in this way, you can add your email address for the notification here and then just save the information. Then we have retries option. This option retry policy states that jobs that fail are retried a number of times based on the following policy. So you can specify maximum number of attempts for a run and minimal interval between those attempts. So let's say suppose if in case your pipeline fails, then you can schedule the retries for, like, let's say suppose one time, for 2 times, so that even if there is some kind of issue, then maybe there are hopes like in the next retry it will get successful. Okay, so it says that one number of retries 1 time, so total will be 2 times. So in this way you can set the retries. You can also set unlimited retries for the same, and once you set the retries, click on confirm. Then we have matrix threshold. You can set the matrix, like duration matrices will be what during run duration, or we have streaming matrices for streaming backlog, or in terms of bytes, duration, files, and records. So you can set set those matrices threshold, and you can save and edit the notification. And then afterwards, you can create the task. Okay. So let's say suppose we will create this task. Then maybe I have created a BI dashboard which is dependent on this pipeline. Okay. So to add that another task, what we can do, we can say add task. In this, I'll click on dashboard. So once I'll click on dashboard, give the name which you would like to have here, and then type would be dashboard. Then first, before this, when you create the dashboard, you need to publish that dashboard. Okay, so once you publish it, then you will get that name here. Then you can select that particular dashboard which you would like to have. Then SQL warehouse, we have only serverless SQL warehouse here. Then subscribers, you can have the subscribers, it is not mandatory, and you can select your email address. Then here it states that run if dependencies. So in which case you would like to have dependencies, and in which case you would like to run your dashboard. Okay, so we have these dependencies like all succeeded. In this, all dependencies needs to be executed and succeeded. In our case, it would be pipeline dependency. So then, like, at least one of them gets succeeded, then none failed. Then we have all done. Then we have at least one failed and all failed. So these are the options which we have under this run if dependencies. Then we have this notifications. Similarly, you can add the notification. You can give email address and set the notification. And similarly, again, we have retries policy. So in this way, you can create the pipeline. Now create the workflow. Now in this case, we have connected dashboard with the pipeline. Okay. So for this, I need to first save the task. So this is how we can schedule our jobs. And then if we'll come to the right side, we have these job details where you can see job ID. Then we have schedule and triggers. Here also you can schedule your triggers. So we have trigger types which we have discussed. Those are here: scheduled, file arrival, and continuous. So if we'll select scheduled, then you can have schedule type simple or advanced. For the simple, you can say every 1 day, every 2 days, and so on. For the advanced, along with these days, you can select particular time when you would like to run your pipeline, and for that time you also need to declare your time zone too. Then you can save it. Scheduled status, it would be active or paused. Then we have file arrival. For the file arrival, you need to give your location, storage location here. So for example, if you have your file stored in volume, then that volume location or S3 bucket path location or ADLS path location, that you need to specify here. Then you can test the trigger and then you can save it. Okay, so in this way you can schedule your file arrival trigger. Then we have continuous trigger. So for the continuous trigger, it states that task dependencies are not allowed for continuous jobs, so remove them to convert to the continuous job. So in our case right now, pipeline and dashboard is connected with each other. So let's say suppose we don't have any dashboard, We are just having pipeline. Okay, let's say I'll just delete this task. Then come to this add and schedule triggers. Trigger type would be continuous. See, now this option is visible. So continuous job is intended to be always running, and it ensures that there is always one active run. So a new run is created as soon as previous one gets finished, okay, due to failure or success, whatever the status is, or when there are none. So this is how we can have continuous trigger type, and it in this also we have retries, task retries. We can say I don't want retries anytime, like if it fails then I just want that status to be failed, or I can retry my task again if I get failure. So when failure is selected, a failed task will retry few times before a new job run is created. So this is how with this advanced option we can create trigger which is continuous trigger, and then we can save this and schedule the trigger. Then we have job parameters. So if you would like to have any parameter to be set for your pipeline, then you can give that parameter here along with certain default value, and then you can save the information. So from here too, you can add your job notifications by giving your respective email address. We have seen this option earlier too for the pipeline and dashboard, and then you can save the information. So this is how this workflow looks like. And then we have the option run now. So once you will click on this run now, then it will start running this pipeline. And we have this option with run now with different settings too. So if you need to opt for this option, then you can go with this. And once you will start running this task, then you can see whatever runs which got created over here. Okay. So right now, let's say we will see the pipeline which we have already created. Okay, this is the task which already I have ran. In this I have one pipeline and dashboard which I have created. You will see the information. Once you will select it, you will see the information below this. Okay, so we forgot one more option which is depends on. So we need to give this option of depends on. Let's say suppose for the dashboard it depends on the bank pipeline, right? So in this case, once bank pipeline gets succeeded, then only we need to run this dashboard. So for this we have this option depends on. Here we need to mention that pipeline name, so it is necessary for that. And then we have this runs option. So once you will start, we have created this task and we have clicked on run now, then you can come to the runs, and here you will see what are the runs happening and what is it doing exactly and how much time it is taking. Okay, we'll see for the bank we had a run for the first time. This information is here, and then once bank is run, then our dashboard has started and we can see all the information over here. So one thing I have observed is, like, when you are using this Databricks free edition, it takes a lot of time to run this workflow. Okay, so earlier when I was working, after 1 or 2 minutes I used to think that I'm doing something wrong, and I used to cancel this pipeline because I was not sure what is exactly happening. So with the free edition, as we have very limited resources, it usually takes 8 to 10 minutes. Okay, so if you see here, it has taken more time than that. So for our pipeline, if you see here, it has taken 12 minutes and 22 seconds. So after 12 minutes and 22 seconds, our pipeline was ran, and then after that this dashboard took 1 minute and 1 second to run the dashboard, and this is the overall time which has been taken by our pipeline to run. Okay, so this was my first attempt, then this was my second attempt, and then this was my third attempt. In this case, I think something has failed and my pipeline was failed. Okay, so for that it shows that it is in red color. So if you'd like to have information of the same, then you can create on that respective job or task, and it will navigate you to that job run. Okay, so we can see that it has allocated particular unique ID for this. So this is the run 481 blah blah job ID, and then under that it has ran our bank run job pipeline. We can see the output of our run. Then we can see list 2. In this we can see all the tables which got generated while creating this pipeline. And then again on the right hand side we have all the details for the same. If you'll click on see details, then it will navigate you to this page where you can see each and every detail in depth. Okay. Then we have edit task option here. If we'll click on this edit task, then it will navigate you back to the workflows where we were creating our pipeline. And from here we can edit whatever we need to, whatever it is required, and then again we can run our task. So this is how overall this workflows look like. So once you will come to this page, we have these jobs pipelines here and job runs here. So under all section you will get everything. With the jobs, it will show you how many jobs we have created. Then under pipelines, it will show how many pipelines we have created. So this is how you can have the information on this main screen. And then job, if you click on job runs, it will not give you anything for the 11 and 12th September. Let's say suppose what happened. I think I have okay, I have selected favorites. I can say owned by me, or I can have filter of access by me. And if you see here all the pipelines, it will give you type. If you have any types, then it will show you who has ran that pipeline. It will show you here with that person's respective email address. Then it will show you runs too. So if you see here, first this run got successful, then afterwards these got failed, then again we got successful. These are the blank runs, these are the cancelled runs. So this is how we can see all the runs whichever we have performed and on that pipeline over here. Then we have this option. With this we can start our pipeline again, and we have this option here. With this again we can navigate and edit our pipeline. We can go to the settings, or we can delete the pipeline if it is not required. So this is how this workflows section looks like. Sometimes it happens that people confuse DLT with the workflows. So with this we can say that DLT and workflows, they both work hand in hand, but DLT is not equal to the workflows. Okay, so DLT is a component that can be orchestrated within the workflows, but workflows can do much more beyond the DLT. Okay, so DLT tells us what we build, and workflow decides when and how to run it. Okay, so together they give us reliable and event driven ETL. But DLT is not equal to the workflows. So workflows, think of these workflows as a big umbrella for the orchestration in the Databricks, and DLT is a specialized pipeline type that plugs into workflows. So within this umbrella of workflow, we can schedule DLT, then we can schedule Python files, then we can schedule SQL queries, SQL files, then we can have another task. So multiple tasks that come under workflows, and we can schedule all these tasks with the workflows, and DLT is one of the tasks which we can schedule within this workflow. Okay. Now we are going to move to our practical part, and we are going to create one project. So for this project, in this lecture, we are going to use Python language. In the next tutorial, we will prefer SQL language. So as of now, we are moving ahead with the Python language to create the pipeline. So this is how our project flow looks like. We are going to create this Lakeflow declarative pipeline. It is gonna be automated Lakeflow declarative pipeline. Okay. So first we have ingestion. So we are going to create, as we know that we are going to follow three naming nomenclature, right? In this we'll have catalog, then schema, and under that schema we are going to create whatever tables we would like to create. Okay. So under this schema, when we along with creation of table, we are going to create one volume, and in that volume we are going to ingest our files. Okay, so this is how we are going to ingest our files, streaming files, into our volume. Once we get all the files in our volume, then we are going to have that data, or we are going to fetch those files in the form of streaming tables, and then we are going to work on that, Then we will create materialized view, again streaming tables or temporary views. So all that things we are going to perform under DLT pipeline. In the DLT pipeline, we are also going to apply data quality checks to get the good data, so that analysis will get our analysis will be we will not have any kind of error in our analysis. And in this, along with this, we are going to follow Mendelian architecture in DLT pipeline, bronze, silver, and gold. So basically what we will do, we will first create one landing layer. With this landing layer, we will fetch the information from these volumes to our DLT pipeline. Then we will have this bronze layer in which we will perform data cleaning. Okay, so we will combine this bronze and landing layer all together into bronze layer, and in this we will have data ingestion and data cleaning. So once we will have this clean data, then we will perform certain transition under silver layer, and once we will have these transformations, then we will have gold layer, and in which we will try to perform certain business aggregations. And once we are ready with this pipeline, in which we have followed this Mendelian architecture, we will create one BI dashboard. So in this BI dashboard, we will use the information which we have stored in the gold layer, which will be of business aggregation. So we will pull this table while working on this BI and reporting, and then we will create certain dashboards or certain charts in our dashboards. And once we are done with this, then we are going to have one workflow in which we will schedule this DLT pipeline and BI dashboard. So this will be our DLT pipeline and then BI dashboard. And BI dashboard will be dependent on DLT pipeline, and then we will try to schedule this workflow, and then we will see what will be the output which we will get after scheduling these jobs. And all this information is going to be governed with our Unity catalog. Okay, so this is how our project looks like, and we will try to create this project of just now in this tutorial. And okay, let's try to understand the data which we are going to use. So we are going to have two types of data. One is customers, and then another one will be accounts with those transactions for those respective customers. So if we'll see, we are going to have 4 sets. Okay, this is going to be our one set, second set. Then this will be the first set for accounts and transaction, and this is going to be our second set. Okay, for this, if you'll see, these are not the sets, I think, actually. Okay, so first we have, okay, so we are going to have data for 2 types. Okay, one for the customers and then another one for the accounts transaction. Okay, customers is going to have the information as customer ID, which is going to be our primary key. Then city, date of birth, email, gender, income range, join date, name, occupation, phone number, preferred channel, risk segment, and status. And in the accounts transaction file, we are going to have account ID, type, balance, customer ID, transaction amount, transaction channel, date, ID, and transaction type. So in this, this transaction ID is going to be our primary key, and then customer ID is going to be our foreign key. So now these files we are going to have for 2 years. One will be 2023 and then 2024. So for 2023, for the customers, I'm going to have 2 sets. Again, for the customers for the next year, which is 2024, I'm going to have 2 sets. Then again, for the accounts transaction for the year of 2023, I'm going to have these 2 sets. And for the next year, 2024, again, I'm going to have these two sets. Okay. So when we are going to create a pipeline, first we are going to fetch, or we are going to load our files. This one, first file, second file, then this will be third file and fourth file. Okay, so we are going to load these 4 files, and then we are going to create pipeline based on these 4 files. Okay, and once we will run this pipeline with these 4 files, then we are going to upload our next file set, which will be this one. So again, we are going to upload, after first run, we are going to upload first, second, third, and fourth file, and then again we will run the pipeline, and then again we will see how our pipeline is going to be updated. So this is how in total we are going to work on 8 files. So let's see how our pipeline is gonna look like. So this is how our pipeline will look like. We will have, as we have decided, landing and bronze, we are going to club it together. But again, this is landing table. These are landing tables in which we are going to load our files. Okay. Then we will perform data cleaning here. This will be our ingestion, and then this will be our cleaning. For this, we are going to use bronze layer. Then we will have this silver layer where we will perform transformations. So here also, like, this is gonna be our silver layer. And once we will perform transformations, then in the gold layer, we will try to perform some business aggregations. Okay. In this, we are going to see SCD type 1, SCD type 2 also. Then we are going to create these materialized views. Then we are going to create these temporary views. Then we are going to create these streaming tables. Then we are going to apply our constraints, which are data quality checks at this layer. So in this complete pipeline, we are going to see all the concepts or most of the concepts which we have seen in our theory part. Okay. So now let's move ahead and start with our practical part. For that, we are going to use Databricks free edition. Let's start with our practical part. So first thing usually I do is to create one folder, and in that folder I try to save all of my works so that going forward, if I'll need that project, then I'll get everything under one row. So for that, I'll select the user, and under this user, I'm going to create one folder. So let's say suppose my folder name would be DLT. Our project will be bank project, or we have the data related to bank, so I'll give the bank name, and then bank project, all files, and then create. So now our folder is created. Now we are going to save all of our work under this folder. The next step would be to create catalog. In that catalog, we are going to create schema, and in that schema, we are going to create volume where we are going to upload our files. So I'll just open new Databricks section, then go to catalog, click on create catalog, then give catalog name as, maybe I'll give this name along with or followed by catalog. Then type would be standard. Storage location, this option is in preview. Let's see when it goes live. Then click on create. So it will state that your catalog has been created. Now configure the settings for your catalog. Now we will say we need to grant the permissions. Okay, so click on grant. Select your account user IDs. I'll say all account user. Privileges, I'll give custom. I'll follow and I'll give all the privileges along with external use schema and manage. And then I'll grant all the privileges to my catalog. Then I'll click on next. Keys and value, we don't need it for this project. And then just I'll click on save. Now our catalog is ready. So under this catalog, we are going to create schema. Then our schema name would be DLT bank project schema. Storage location, as of now, we don't need to give any storage location because we are going to use volume which are already present in our Databricks. Comment, no need to give, click on create. So this is our schema. Now in this schema, we are going to create volume. So volume, then we are going to give volume name as DLT project bank volume. And then we have two types of volumes. One is managed and then another one is external. So right now in our case, we are going to upload the files into our volume, which is present in this Databricks. So for this managed volume would be fine. External volume, you can refer it when you are using third-party source, and that external resource you would like to have it here. So for that, you can use external volume. So as of now, for our project, it is going to be managed volume. Click on create. Now in this volume, we are going to create two directories, one for the customers and then the second one for the accounts and transactions. So let's click on create directory. The first directory name would be customers. Click on create. Come back. Then the second directory would be for accounts. We'll click on create. So you have the option to upload your data to this volume or to this directory by clicking on this upload to this volume. So from here also you can upload respective files to the respective directory in the volumes, or else you have option from here to jobs and pipeline, then go to ingestion pipeline, then you have upload files to a volume. From here you can select your volume, catalog, then select schema, volume, and then first let's select customers, and here we are going to drop our files. For this, our files would be, first we will upload customers 2023 set 1 and set 2. Click on open. Click on upload. Now we have uploaded two files. Now again we are going to upload another files into our accounts directory. So here again we are going to upload 2023 sets, both the sets set 1 and set 2 for this accounts and transactions. So those data would be these two files. Click on open and then upload. So this is how you can upload your data using this ingestion pipeline option. Now we have uploaded our data, and then we are going to work on our DLT pipeline now. So for this we are going to click on this ETL pipeline option. Here we are going to give our pipeline name. So we will follow the same naming convention here. Our pipeline name would be DLT Bank Project Pipeline. Then workspace, here you need to select your catalog. Even if you don't select it, going for like in the next part, I'll show you from the settings we can select that too. Then here, I don't see my catalog. Let's just refresh this page again. Our name, let's just first select it, okay? Okay, DLT Bank Project Catalog. Then schema would be DLT schema. And using this schema, now we are going to create DLT pipeline, okay? And in under this schema, we are going to have our tables. So I'll just give the name again. So here, as we know that we are going to code our pipeline with Python language, so we are going to select this option. So select start with sample code Python. So this is our pipeline under which we have exploration, transformations, and utilities. This is our coding part, and here we can see our pipeline graph. And at the in the bottom, we will get the output in the form of tables and performance. So whatever I'll show you on another option. If you click on select, settings. So if you would have forgotten to select or to assign catalog and schema in the first step, then you can add your catalog and schema from here too. Or if you would have given wrong catalog or schema, you can edit that from here. Now if you see code assets, root folder is our this pipeline name, which is this one, and then our source code would be transformation. So whatever we are going to write under transformations, that part is going to reflect into our pipeline, okay? So if you'll see, we have these two sample codes which are given by Databricks, which are already present. So when you will run the pipeline along with your code, these two codes are also going to display here in the pipeline graph. So to avoid that, if you have option, then exclude as a pipeline source code. But if you don't have that option, you just move your code from transformations to the explorations. Then move And then we will also move the second part. So as we have moved it to the explorations, now we are going to move our complete pipeline information or pipeline files to the folder which I have created at the start. Okay, so for this you are not going to copy paste anything, so just click on these three buttons, three dots, and say move root folder. So once you will click on move root folder, go back to your, where is that folder, this, the users, then this one, then we have this DLT bank project all files, and we are going to move our all the files here. So this is done. So this symbol indicates that whatever we are writing in this file, that is going to be excluded from the pipeline. Okay, so usually what happens, this sample exploration, right, we usually prefer it here, prefer to check if our tables has been created or not, or if our tables has been created, then how it looks like, what is the information stored in that. Okay, so for that you can select this, use this sample exploration. Let's say suppose I have created one table, then I can have the code, I'll select star from that respective table name, and I'll see the output, how it looks, and if it is as per my requirement or not. Okay, so for that we can use this sample exploration. From here also you can have these coding, or if you would like to have another file just for the sake of your additional information, then you can create that Python file from here. Okay, so click on notebook, and here we will have our work, which would be, let's say, rough work. So there is no difference between this, but as we are using free edition, then the compute, it takes a lot of time when we are working with this sample exploration. So to avoid this, I just create another notebook in the folder which I have created earlier, and I check all the information or all the tables, what information they are having over here. So it's one and the same thing, but to save my time, I just prefer doing my work here. So this is the sample exploration. Now if you click on this, then pipeline graph, it will be removed. Sorry, it will be hidden. Now under these transformations, we are going to create all of our files. Okay, so I'll click on these three dots, then I'll say create file. So first file I'm going to create with Python language, and let's say give this Python file name as maybe landing layer. Okay, dataset types, you can select whatever dataset type if you would like to have. Even if you don't select, it doesn't go, it will not make anything difficult going forward. So I usually don't select anything, and any which ways it's optional. Click on create. So now here we are going to work, and we are going to fetch all of our information which we have stored into our volume. So I'll just quickly duplicate this, and I'll open this catalog. So I usually keep all the work parallel, so that instead of using one section for all of the things, it's better to have different tabs open for the same. I'll just open here catalog and our respective schema, because we need to assign some paths from here, so it would be better to navigate from the different tabs. Okay, so that's fine. Come to the landing layer. Now first what we will do, first we are going to ingest our customers data. Okay, I'll add the comment customers 2023 data ingestion. Now first things first, we are going to import our DLT. Okay, import DLT, and then import all the SQL functions and types. Okay, so once we are done with this importing, then we are going to create our first streaming table. Okay, now our streaming table, for this we need to use decorator dlt dot table. Now we will add some information in this. This is completely optional. So this is, I'll write table name here. Let's say suppose our table name would be landing customers incremental. So this same table name we need to give for the function name, and then let's say I'll add one comment, landing customers data. Okay, so this information is fine and this is completely optional. Now after this DLT table we are going to say, and we are going to define one function. So that function name needs to be this one. So def incremental, then parenthesis colon, and here we are going to use now our autoloader. We have already discussed how autoloader functions. So let's say return, and in return we will use spark.readstream. Our format is going to be cloud files. Then cloud files format is going to be CSV. So we will change this to CSV. Then we don't need this. After the format, we will say options. In the option, we will say cloud files dot include existing files is equal to true. Then we are going to use option for header true. Then we are going to define our schema. So for that we have dot schema. We are not going to say import schema in this situation. So for this, what we can do, we can declare one schema here. So let's say suppose before schema, I'll keep this blank, and then I'll have the option of load. And then we need to give our path of our customers here. So this, click on this, copy path, and give that path here under inverted commas. So this is going to be our data which will get loaded, and it will create streaming table because we are using read stream named as landing customers incremental. So now we are left with schema. So for this, let's quickly create one schema here. So we will define one schema for our CSVs. So let's say suppose our schema name would be customer schema is equal to struct type. Then we have customer ID. We will keep it as integer. Then we don't have first name, we have name. It would be string type. Then we have DOB. Struct field. I'll give it as DOB, comma. DOB must be of date type. True. Then after DOB, I have gender. Gender string type would be fine. Then I have city. City string type would be fine. Then I have join date. So this would be join date. This type would be again date type. Then I have status. Status string type is fine. Then I have email. Email with string type is fine. Then I have phone number. String type is fine. Then we have preferred channel. Again string type is fine. Again we have occupation. string type, and then we have after occupation we have income range, and after income range I have risk segment. So these are my column names which I have into my CSV file. Now let's close this struct type. Now we have defined our customer schema. This name now we are going to give it here. Okay. So this is how we are going to create our first streaming table. Okay. So we'll just use dry run, and now it will start preparing for the new graph, and let's see how it functions. Okay, so now our pipeline is failed in the dry run because it states that number struct field is not defined. We have done here one typing mistake. So let's just correct it. Now again have dry run. So usually to create or to prepare first graph, it might take some time. Okay, so if you'll click on this maximized, toggle this maximized, then we can see that we have this streaming table. But there is no data available as of now because we have done dry run and we have not ran our pipeline. Okay, so because of that we don't have any data. This table is not created and we don't have any data in this. Once we will do run pipeline, then this table will get created. But we can see the columns along with those respective data types. Table matrices, column or catalog schema type, performance, it is not available right now. So just minimize this, and now we have done customers 2023 ingestion. We'll do now accounts, transactions. So this is the one file only in which we have both accounts and transaction information. Okay, for that let's try to create one table. So we are going to create the table in the same way, and this is going to be our streaming table. So we will paste it here. Our table name would be landing accounts transactions. Make sure to give this name over here. We need to change this, and then we need to change this file path. So account, select accounts, come to catalog and volume, into that volume and select this folder, copy this path, and then give that path name here. Now we need to define structure 2, and our structure name would be, we need to create schema 2, and our schema name would be account schema, and we will create that struct field over here. So it would be account schema equal to, we are going to use struct type for this. We have account ID. So for this we are going to give, let's just check our data first. So for this, customers. Okay. We have customer ID, name, POB. Okay. So these are integers only. No, we need to check accounts, right? Where is that data? Okay, these are integers only. That's fine. So now account ID integer type is fine. Customer ID. Maybe we will give long type. Here also we will give long type. Then we will have account type, string type is fine. Then we have balance. Then we have we have first tax ID. We just after account type we have balance, and then we have transaction ID, not tax ID, TXN ID, which would be long type. Then we have this transaction date. It is TXN date. Date type is fine. Then we have transaction amount. For this we will give double type. And then we have, lastly we have transaction channel. So TXN channel. And then closing parenthesis. So this is how we have typo mistake. So SCHEMA it should be there. And I have checked, I have given this wrong name too. So for this, click on this, click on rename, and from here you can change it. From here to, if you will double tap on this, from here to you can change it. So this is how we can create our second streaming table as of now. So now let's just click on dry run. So if you'll remember, in these two folders we have two files, okay, set 1 and 2, one for 2023 year. So for accounts, this streaming table is going to read both files, okay, using Autoloader, and same goes for accounts or customers. From here to, it is going to read both of these two files, okay. So now let's just check. So it seems that we don't have any error. So now let's try to run the pipeline and let's check how much data we are getting here. Okay, so our run is complete. If we'll maximize this, then we can see that we have in total 1.2k entries, and for the incremental customers incremental we have 200 entries. Now for the customers, if we'll see here, we have 100 into set 1. Now we'll check set 2 for the customers. Then again we have 100 entries. That means that total 200 count would be there for the customers. And if we'll check for the accounts, so for the account set 1 we have 564 count, and let's just check for set 2. Set 2. For this we have 665 count. So altogether it is around 1.2k. That means that our streaming table is working fine and correctly, and this streaming table is reading both of the file which we have uploaded into our respective directories in the volume. And if we'll click on this any one of these table, now we can see all the data which we have under this, okay. So now if we'll see transaction amount, we are getting null values, but for the accounts, right? Okay, but we have transaction amounts present. So this is happening because we must have done some data type changes, or that given data type is not working. Here transaction amount we are getting null values, and in the transaction channel we are getting the amount values. That means that our fields are not getting mapped properly. So for this we need to add transaction type after this state. So we have missed that one column. So TXN type, and then it would be string type. Now we are going to run our pipeline. So here let's just run the pipeline first, and then we'll see what is happening exactly. So our run is complete, but if you'll see, we don't have any additional value, because whatever values or whatever information or whatever data which we were having, that is already present here. So that means that output records that are reprocessed after second run, those records are zero, blank. Okay, so in this situation what we need to do, we need to select run pipeline with full table refresh. So this is not the recommended way when you are working in real life scenarios, because you must be having millions of data, and you have stored that data, and you are running full table refresh on the same, then it is going to take more time, and your pipeline is going to break, and more than that it is going to cause the problems, because you have certain data which is already stored, and that is important for your business. So it is not the recommended way, but as we are doing this project to understand and for the better clarity, we are going to use this option often, which is run pipeline with full table refresh, so that we will get to know that after each step what is exactly happening and how much data is getting updated. So for that only we are going to opt for this option. So click on this option, start full refresh. It will state also that full refresh will truncate and recompute all the tables in the pipeline from the scratch, and this will lead to the data loss for non-idempotent sources. So are you sure to opt for this option? Okay, so as of now we are going to start with the full refresh. So now it will maximize this, it will check this table data. Now we can see we are getting data as expected. Okay, columns, now we have all the columns, table matrix, catalog, schema, type. We didn't set any expectations here, so as of now expectations are not defined. We'll go to the customers and then we'll check the data. Okay, so this data is at least ingested properly into the table. Okay, streaming table which we have created in this DLT pipeline. So now we are done with ingestion, data ingestion for the landing layer. Let's create one. Now let's create another file for the bronze layer work. And in that bronze layer, we are going to clean the data. So for data cleaning, mainly we are going to work with data quality checks. Those are nothing but our constraint. So I'll give the name as bronze layer, and we are going to opt for Python language. Create. Now let's start with our data cleaning part. So first we will do data cleaning on our first customers table. So before this we will import all the functions and the types, and also DLT we need to import. Then we are going to create one new streaming table. So here we will create new streaming table which will fetch the information from this already created existing streaming table, which is landing customers incremental. And once we will pull that information into our new streaming table, then we will perform data cleaning on that streaming table. So the first one, so the first, let's use DLT decorator to create our streaming table. So for this, I'll give the name here. So the name would be Ron's customers ingestion cleaned. Then I'll add comment. So these are optional things, you can avoid it if you want. Then we will create one function. Okay, and in this function we are going to perform data cleaning part. So let's just fetch already created streaming table here. So for this we will use data frame, and then we will say DLT dot read stream, and in this we will give already created streaming table name, which is bronze customers, sorry, landing customers incremental. So now all of our data cleaning part we will perform here, but before this we are going to add our constraints. So as we have seen earlier, the constraints, that part comes in the middle of this section where we are creating DLT table and then where we are defining our function. So in the middle of this we can declare our constraints. So these declaring these constraints, these are also nothing but data cleaning part. So we can have data cleaning using constraints, and then for the rest of the things we will use Python to clean that data and perform some kind of transformations on the same. So let's try to use constraints. So as we know that we have three types of constraints, which is expect or fail or expect or drop, and the third one is expect. So here we will try to utilize all of these three so that we will have the idea of like how these constraints function. So first let's try to have expect or fail. So this is our table and this is the information. Our information or our data looks like this, and on this table we are going to perform our data cleaning. So from here we will get the idea like what kind of data cleaning we need to perform. Okay, so first we will try to utilize this customer ID column. So here we will give the name as customer valid customer ID, and then we need to give comma, and then we need to define our condition which we would like to have as a part of constraint. So here we are saying is that customer ID is not null, and we are saying expect or fail. So as customer ID is a primary key, we need that primary key any which ways, right? You can't have primary key as null value. So for that, what we will say, if we will get any primary key as null, then we are going to fail our pipeline. So for that, we can use expect or fail for this customer ID. Now, for the next, we can say DLT expect or fail. Now for the customer name, we will say expect or drop. So if you have any null value in this name column, then we are going to drop those values. Okay, so here we need to make sure that our column names are given properly. So here our column name is name, so we need to give that column name as it is. Now the next one would be for expect or drop, and then we will have it for DOB. And same, we need to say that DOB is not null. Then we have gender. So for the gender, we will look into gender afterwards. So after this, what we will do, we will have city, valid city, comma, then our condition would be city is not null. Then we have join date. So here we need to say that valid join date, and then join date is not null. Then we have status. Status we will look after along with gender. Okay, so after join date we have email. So for this we will say valid email, and email is not null, but along with this we will specify one more condition with and statement. Oh sorry, by combining with and. So here we will state that our email ID needs to be in proper format. Okay, so we can see that we have @example.com. So this is invalid email address, right? So similarly we are going to have such kinds of invalid email addresses. So for that we will have and condition, and we will use r like. Then we will say in the inverted commas we will put our condition, and our condition is going to be, we need to check that if our email addresses has values from A to Z and from 0 to 9. And then we need to have at the rate, and after at the rate we need to specify the condition, and after this we need to say that we are going to have dot and again A to Z condition, and after this we will have at least two values, right? Dot in or dot com. So these condition we are going to specify it here for the email. Then we need to enter the condition for phone. So for the phone too, we need to add specific condition because we have certain invalid phone entries. But this condition or this cleaning part we will do afterwards in this section. So as of now, I'll just say I just need to check if it is not null. Okay. Then after phone we have valid channel. So for that channel is not null. Then I have occupation. Where occupation should not be null. Then I have income. So income needs to be not null. And then I have risk segment. So now till this we have seen expect or fail or and expect or drop. As we have seen expect or fail and expect or drop, now we are left with gender and status. Okay, so for this we will use only expect, because going forward I would like to have the condition as if gender is null, then we will replace those null values with unknown. And similarly goes to status. If we have status null, then we are going to replace those null values with the unknown. So for that, I would like to have those null values going forward. So for that, I'll just say DLT.expect. Okay. So this will just give me the warning, but it is not going to drop our entries for gender and status. So for this, I'll have expect condition gender and gender is not null. So this condition, in condition, we will give afterwards. I'm not going to give this here. So as of now, this is fine. And then after gender, I'm going to have status. Status is not null. So now, first we will run this section and we'll see if we are able to create this table or not. And then we will apply our remaining data cleaning part here. Okay. So again, I'll have run with full refresh table. So it is giving me some error regarding this email address. So let's just diagnose the error. It states that we are using this R like incorrectly. So now let's see how Databricks helps us with this correction of the error. It said that it should be in single quotes and also regret pattern is invalid. Okay. So now let's see how Databricks helps us. So now let's replace our code with this given code. Now let's try to run this again. states that it didn't find the key. Okay, so first let's try to create this table. So as of now, I'll just comment these expectations and now I'll run the pipeline. Now we can see that our table has been created and we are getting as expected output in the table, which is right now we haven't cleaned anything. Okay, so as of now I have commented all these expectations. So now we'll try to perform data cleaning for the rest of the columns. Okay, so the first thing would be, now we have all of our information in this data frame. So we are going to use the same data frame where we will try to convert or try to change the cases of respective columns to either uppercase or lowercase. Okay, so let's start with name. So name we would like to have in uppercase. So I'll use upper function on the column for name. Then, so the next one is occupation. We'll convert it to uppercase. Then afterwards we have city. We don't have address. City would be in uppercase. Then after city we will have income range. Then we have risk segment. Then we have preferred channel. And lastly we will have, okay, so income range is done. Then risk segment is also done. So I think we are pretty much good with this. Now what we will do for the gender, here for the gender, if we will say if it is M, then we will change it to male. If it is F, then we will change it to female, and null values we will replace it with unknown. Okay, so for that we will use our column gender, and we will have when condition. When gender is M, then male. Then again we will apply when condition. Again when. Gender is F, then female. Otherwise we will replace those values with unknown. Column M, then male. Then when column is gender, then female. So when column gender is F, then female. Otherwise we will have unknown value. Okay, now similarly we will do for status. So what we will do, if status value is blank, then we will replace that with unknown. Okay, so for that we will have df with column status, comma, again we will use when condition, when column status is null, and we will have or condition here. More, we will trim our column status is equal to blank value, then we will change the values with unknown. Otherwise, whatever the status will be, we will have that status. Okay. Now we are done with status column. So now we need to work on phone numbers, because as we have seen, we have certain null values and then certain invalid phone formats. So for that, what we will do, for the phone, first we'll have with column, and then our column name would be phone number. First, our trim all the phone number values. Then we will use regress replace. Then we are going to use filter on the phone numbers. Filter column this, and then we will use this r-like function, but we'll do certain changes here. So this condition we are going to change. I think before this we are going to add plus 44, and then we will have this remaining condition. So this is how we will get correct phone numbers in our phone number column. Now again we are going to use filter function for 3 columns. One would be preferred channel, then income range, and risk segment. So for the preferred channel, if we'll see, we have these 3 values. Okay, so this is the incorrect value we have, which is ONLNE. So what we will do, we will filter our values and we will have only these 4 values. Okay, then for the income range, we will filter our values to only these 4 ranges, and similarly for the risk segment, we will filter our values to these 4 values. Okay, so for that, first we will use filter on preferred channel, and then need to use column here, column preferred channel, and then we will use is in, and then we need to enter all of our four values. So the first one value was mobile, then we have online, then we have branch, and then we have ATM. Similarly, we will use it for income range. So the income range was high, medium, low, and there was one more value. Which one was that? That was very. So the next value was very high. And then for the risk segment, it was low, medium, high. And I think we were having one more value, and that one was unknown. So I think we are pretty much done with our data cleaning part. So now let's dry run first, and then we will run our pipeline. Okay, so before this, we need to uncomment these expectations. So it states that channel cannot be resolved. So let's just jump to the code. Okay, so the column name was preferred channel and not only channel. Now let's try run it again. Now it says that when is not supported. So this is the correct syntax for that. Now let's try run this. Unexpected indent, okay. Now let's try run it. Okay, so I think I have done some mistake in the parenthesis. So this is going to be our correct syntax for the same. Let's just comment this. And here also I think we have done some mistake. It needs to be REGEXP. Okay, so hopefully this will resolve our error. Okay, so again we have done parenthesis mistake. So this needs to be like this. Now let's just check it again. Before running the pipeline, I was getting error. So there were two minute changes which I needed to do. So here I just said channel. So it needs to be a proper column name. So it needs to be preferred channel. So I have replaced channel with preferred channel. And then here to preserve +44 from the phone number, I just needed to add this plus sign over here. So earlier it was not there. So I have done that. Now we will dry run. So now we will run the pipeline with full table refresh. Now we can see that this table has been run successfully, and now this table is also run successfully, and now run is complete. So we'll see. Now we are going to check what's the outcome after this data cleaning. So this is the table which we need to check. Okay, data ingestion cleaned. So if we'll check this, this is how we are getting our data as expected. Like whatever transfer or whatever data cleaning part we have done on this, it seems working fine. Okay, so now we are going to do data cleaning on our second file or the table, which is accounts transactions files. Okay, so for this again we are going to create one new streaming table. So that streaming table name would be, let's say, bronze accounts transaction ingestion cleaned. Okay, then we are going to define our function here, and then we are going to read our earlier table, this table, landing accounts transaction incremental. So this is we are going to pull. Now we will have our cleaning part here, and then we are going to return our data frame. So now before this we are going to add our constants here. Okay, so for this what we will say, this account ID, customer ID and transaction ID, right? These are our main columns. So for this we will have the condition of fail. Okay, because if we don't have these values, that then it doesn't make any sense that we have correct information. So for this we will have expect or fail for account ID, then we will have the same for customer ID, and then for transaction ID. This we need to replace with TXN ID. Then it needs to be fail condition, not drop. Now for the rest of the things we will have expect or drop. We are left with account type, balance, date. Now let's work on those columns. So the first one would be account type. Then we have balance. After balance, I have transaction date. Then I have transaction amount. Then transaction type. I think after amount type we have channel. We don't have status. And we also don't have description. Now we will have rest of the data cleaning part here. So what we will do, we will convert our respective columns, which is account type, transaction type and transaction channel, to the uppercase. Okay, so for this we are going to use the same data frame. So df is equal to df with column, then we are going to convert it to uppercase. So it was account type, then transaction type, and then transaction channel. Okay, then we will check for transaction type. Let's check what entries we have. So if we'll see, we have debit, credit, and again we have credit, debit but with incorrect, what we can say to this. The wording is not correct, so it has DEIT and it has BITT. So we need to change it to proper debit and credit word. So for that, what we will do, we will use df function, and then we will use with column for txn type when we need to use when condition when column txn type is equal to EEBITT or DEBIT, then I think this one is suggesting us wrong. So we are writing this condition that if we have word as DEBITT, then we are going to change it to DEBIT to the correct word. Okay. Again, we will have when condition, and then again we are saying that if the type if that word is CREDITT, then we are going to change it to credit. Otherwise, whatever value which we are having, keep it as it is. Okay. So this one is done for transaction type. Now let's just check transaction channel. Okay, so these channels are fine. Branch, ATM, online, mobile, and app. So, okay, we don't see any kind of issue here. I think this data cleaning is enough for this accounts table. Now let's run our pipeline with full table refresh. And now we will check if we are getting expected entries or not after data cleaning part. It is still running. I think it's done. We'll check. We have set our expectations, which we can see here. And after setting these expectations, it will show how many values we have dropped. Okay. So now we are supposed to check this column. So we'll see. We are getting the expected output. Okay. So for the transaction amount and balance, I haven't removed negative values deliberately because any person can have negative balance or that customer or account holder can have negative values. Okay, so it doesn't make any sense to remove these negative values for the transaction amount and balance. So this is how we are done with our bronze layer work where we have done data cleaning part, and till now our pipeline looks like this. Okay, so now we are going to perform some data transformations, and we are going to have silver layer for the same. So I'll create new file from here and I'll name it as silver layer, and we are going to have Python language. Now we will create this file, and this is where now we are going to perform our data transformation for our two tables. Okay, now let's start with our data transformation. So first we will import all the functions and the types and DLT. So I'll just copy this to silver layer. Now we are going to do data transformation for customers table. So for this, again we are going to create one new streaming table. So we are going to work on this. Okay, so this is going to be our data. Now let's create new streaming table with the name silver customers transformed. Then comment transformed customer table, and then we are going to have our function with the name silver customers transformed. In here we are going to read our customers ingestion cleaned table. Okay, so you can use return to, and in the middle of this, after this, you can write your data transformation code, or you can use data frame 2 to read that respective table, and on that you can perform transformations. So it's fun and the same thing. So let's use Spark read stream table, and then we will read our table, which is this one. Bronze customers ingestion cleaned. Return df, and now in the middle of this we are going to write our code. So let's try to calculate the age of that respective customer based on this date of birth. Okay, so for that, what we will do, we are going to use the same data frame with column. Now we are going to create one new column. So let's name that column as customer age. For that, we are going to use our column. Let's first use when condition for that DOB column. If it is not null, then we are going to use floor, and then we will use months between. Months between, and then current date, comma, we will have DOB divided by 12 because we have 12 months. Otherwise, we are not going to have anything. But for this, we will use let function, and then none. So this is how we will create one new column named as customer age, and we will calculate the age of that customer. Okay. Now we will calculate the tenure days based on join date. Okay. So for that, again, we will use the same data frame with column. New column name would be tenure days. We will have when condition. When column join date is not null, comma, dated if current date column join date, otherwise we are going to have none, and in that we are going to use filter where we will see, okay, there is no need to use filter here. Now what we will do next we will have for this DOB, right? let's for example we'll have that one particular date, and whoever is born before that date, we will mark it as we will have one column named as DOB out of range flag, and in that, if that particular customer's birth date or date of birth is less than that particular value, then we will have that column marked for that. Okay, so for that, what we will do, we will name it as this will be our new column out of range date or flag. For this, we will use column DOB, where DOB is less than 1911, or we will add one more or condition to this, or column DOB is greater than current date. So in both of these situations, we will mark this new column. Okay. Now the next one would be we will add one more column which we are going to need for while using SCD1 and 2. So that column name would be transformation date, and this transformation date is going to be our current timestamp. Think we are pretty much done with the transformation. Now let's try to check. I think we are going to get error here. We have done some mistakes while giving parentheses. And one more, we need it here. Okay. Now let's run the pipeline. Now let's check if we are getting expected outputs or not. We have new column transformation date. It is calculating customer's age too. Then we are getting tenure days too, and date of birth range. False, 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 false. This one is true. We can see that this date is greater than current timestamp, so it has been marked as true. Tenure days. Okay, so from 2023, it is calculating tenure days. That's fine. Customer's age. This is giving -74 because it is giving us future date. Okay, that's why this flag has been set as true. So for this, I think that's fine to have this customer's age, because we don't need to filter it, because any which ways we are marking this as out of range. So as we are marking this column as out of range, then that's fine. We don't need to drop this age, and we don't need to use filter for the same. So now let's try to do transformation on our next table, which is transactions table. Again, for this, we need to create another table named as silver. Maybe we'll say silver accounts transactions transformed. It's my practice to add the comment. You can avoid it. And in this, we are going to use this ingestion cleaned table. Okay, so this table we need to use. And then I'll just say here first return df. Now let's have our transformation in this section. So for this, we are going to use our data frame df. Now let's see for this channel, right? If the channel is physical, I think we don't have physical value here. Okay, so okay, I've done mistake. So if we'll say if the value is ATM, then we will say we'll create one more column named as channel type, and in that we will mark it as physical. And for rest of the values, branch, maybe for app, mobile and online, we will mark it as digital, and for ATM or branch, we will mark it as physical. So for this, what we will do, we need to use with column. Then we are going to have new column name, which is channel type. For this, we are going to use when condition. When txn channel is equal to ATM, then we will mark it as physical. Otherwise, we will mark it as digital. So as we have decided earlier, we were supposed to mark this column as column value as physical when we will have transaction channel as ATM and branch. So for that, I have just added this condition into this. For this, we will mark it as physical. Otherwise, our type is going to be digital. Okay, so this one is done. Now the next, what we can do, maybe we will, for this transaction date, we will create three columns. For one will be for transaction year, then another will be for transaction month, and then we will have transaction day of the week for this date value. Okay, so in this way we will create three new columns from this transaction date. So for that, what we can do, for this we will use df with column. We will say transaction year, txn year as our new column, comma, then we will use year function on the column transaction date, and then again we will use the same for transaction month, and then we will have it for transaction days of month. Okay, we don't need to go till hours. So this is how you can use it, or what we will do to simplify it, I'll just say dot with column in one go. So dot with column. So this is how we will get three more columns. So now next one, what we can do, we can create new column as transaction direction. Okay, we will use it on this column. So if why didn't change CREDIT, we need to go to data cleaning. Okay, CREDIT. that we need to replace it to credit. Okay, so now that will get changed, but for this what we are going to do, if the type is debit, then we will say transaction direction is out, and if the type is credit, then we'll say transaction direction is in. So let's try to apply it. Df is equal to dot with column transaction direction. We are going to use when condition, when column txn type is equal to debit, then out, otherwise we need to set it as in. Okay, so in this way we can do this transformation. And again we are going to add one more column for the current timestamp. We will give that name as account transformation date, because we are going to need that for our slowly changing dimensions change. So it would be maybe ACC transformation date, and that column values would be our current timestamp. So now let's try to run our table. Till now we have done data transformation on both of the columns. So now let's see if it is working fine or not. Okay, so silver accounts transformed. We need to cross verify this data. Okay, so now it seems that it is working as expected. Okay, so now we are done with our transformations. So till now what we have done, this one was our volume. In that we were having customers and accounts directories in which we were having values. So we pulled these values all together into these two streaming tables. Here we can say that this one was our landing layer. Then we have done data cleaning part with this bronze medallion architecture layer. Then here we have done some transformations, and we have given this layer as silver layer from our medallion architecture. Now we need to perform aggregations and we need to create gold layer, but before this we will see how we can apply slowly changing dimensions. Okay, so for this what we will do, for maybe for customers we will apply slow SCD1, and for this we will apply SCD2. We are going to see how it functions afterwards when we are going to run our pipeline for the second and third time. But as of now we are going to apply SCD1 and 2 here, and maybe what we will do, as we know that we have apply changes and auto CDC for both to apply these slowly changing dimensions, right? So to see how it functions, maybe what we will do, we will use apply changes here, and here we will use auto CDC. These both functions the same, but for our understanding and to check how both of these functions, we will use apply changes for one for these customers and apply changes auto CDC for SCD2 for this accounts and transformation. So we are going to create two new tables, and for that these two tables are going to be source table. Okay, now let's see how we can do that. So I'll again come back to this data transformation, and below this I'll write down my code. Here we are going to apply SCD1 using apply changes. Let's see. Now for this table is going to be our target table, but before that we need to create one source table too. Okay, so for that what we will do, we will say DLT dot create streaming table, and our new streaming table name is going to be silvers silver customers transformed, and then we will say SCD1. So we are going to treat this table as target table, and our source table is going to be this table. So again, what we will say, DLT dot. Now we need to use apply changes. So this is the syntax for this apply changes. Target is going to be this one, source is going to be this one. Key needs to be unique identifier. In our situation, it is going to be customer ID. And sequence by, as we know that we are going to create one new column, we are creating new column here, transformation date, that we are going to here to have sequence by. Then we will say stored as SCD type, and then we need to mention which SCD type we need to apply. As of now, DLT is supporting SCD type 1 and 2 only. Now, except column list, like in this new table, if you would like, if you don't want any column from the silver customers transform, then you can have the list over here. So as of now, just to check if it functions or not, we will have just column transformation date over here. And now we need to close our parenthesis. So this is how we can apply SCD1. Now let's run our pipeline and see if it is functioning or not. So I have clicked on run pipeline. So I would have done run pipeline with full refresh. Now our run is complete. So this is the table which got created, and this is our output for the SCD1. So as of now, it is not going to show any changes because we need to change some of the entries and then need to cross verify if this SCD1 is working fine or not. But we are going to do that afterwards altogether for both SCD1 and 2. So till now, what we have done, now we have applied SCD1 to customers table. Now similarly, we are going to apply SCD2 but for the transactions table. So I'll come down to our transformation section, and here I'll write my code. So we are going to apply SCD2 using auto CDC. Now let's do this. Again, we need to create one more streaming table where we are going to save these SCD type 2 changes. Okay. So, and that is going to be our target table. So that one will be this silver accounts transactions transformed SCD2, and our source is going to be this one. So similarly, now we need to use auto CDC. You can use apply changes to here. It's one and the same thing, but we will see with create auto CDC flow. Again, we will have target, source, then we will have keys. So keys needs to be unique. In our case, our primary key here is transaction ID. So I'll give that unique identifier here. Then sequence by, we have created new column, which is this one, which will have current timestamp. So I'll give this as sequence by. Then except column list, I'll give this one, and afterwards I'll say stored as SCD type 2. So this is how we can apply SCD2. Now let's see if this is creating new table or not. Okay, so now our run is completed. So this is the table which we have created now, and this is the data, and this is the information which we have. Now if you'll see, it has created two more columns, start at and end at. So now for this, let's say suppose for transaction ID 1, for this condition, If this transaction channel, let's say suppose, changes from online to branch. So in this situation, when I'll rerun the pipeline, this SCD2 is going to be populated with two entries for this transaction ID 1. So this entry is going to be filled with this end at. So let's say suppose I have ran this for 14th of September, then it will populate this end date as 14th of September, and it will create one more entry for the same and the start date for that. For that, this channel type is going to be branch, and this start date is going to be 14th September, and this end date is going to be null. So in this way, if I'll change any one of the value, then SCD type is going to keep those history values with end date, and then it is going to create the new value also. So in this situation, as we have created second new value, so as a history, it is going to keep this first value, and then it is going to have that second value too. So this is how this SCD type 2 is going to function. However, for the SCD1, it is not going to keep any history. Okay, so for the Henry White, if I'll change the city from let's say Etobicoke to Toronto, okay, and then I'll rerun this pipeline, then it will simply remove this and it will change it to Toronto. It is not going to keep this history of the customer that this person was having the city value Etobicoke earlier. So you won't be able to track any kind of history using this SCD type 1. So this is how this SCD1 is going to be behaving. Now we will see, actually we can move ahead with business level aggregations for our gold layer, but in the middle, let's try to see how we can create the view. There is no need to create view here, but for our understanding, we are going to create two views. Okay, so one view we will create for this accounts transaction, and then second view we will create for this. It has no purpose in this project, but it's just for our understanding. So now I'll move upward where we were doing transformations for customer table, and after this SCD1 I'll have view. Okay, so to create a view, we need to use decorator, which is DLT view, and the name of our view is going to be we will give this name followed by view. So this is going to be our view name. This is going to be our temporary view. Okay, comment now we are going to use function. We are going to define function with the view name, in which we will use read string for this. Read string dot table, and in here we are going to read our table, which is this one. Okay, so similarly we are going to create the view for transformations too. So I'll come downwards, I'll paste the code. It's just that I need to change the naming conventions. So here we need to read this table. Our name for the view would be transformed view, and this name we need to give here. Now let's run our pipeline. So if you see here, whatever tables we are creating, from the past table. Let's say suppose this table, what happened? Jump to the code. Okay, it should be written spark dot read stream, not DLT. Now we will again run our pipeline. So it will take some time to prepare a new graph. So if you'll see here, our graph is running, but whatever we are doing, so let's say suppose we have created this streaming view or this view temporary view from by using this silver accounts transaction streaming table, right? But nowhere we have given this lineage, right? So this lineage, right, which table will run after which table, and afterwards what that table is going to do that, or what table this table is going to be a source table. So all that is Databricks is figuring out. So we are not doing anything over here. So rest of the backend things Databricks is doing, and right now we are just writing the code for that, for those respective tables, okay? And rest of the things Databricks is doing that. So this is how we can create streaming table and the views, okay? Now after this we are going to move forward to our business level aggregations, okay? So now we are going to have new layer here, okay? And here we will do some business aggregations for our gold layer. So now we will move ahead for that. For this we will create one new file under the transformations. Let's name it as gold layer. So this is where we are going to code for our business level aggregations. Now we will try to join our tables. So as we know that these are our temporary views and these are our SCD 1 and 2. So what we will do, now we will create in the business level aggregation, we are going to create one materialized view. So this is going to be our materialized view, and in that view we are going to join our two tables. So these are going to be these table, customers table and accounts table we are going to join. So we can use maybe left join or inner join, we can use outer join, we can use. So right now, as of now, we will refer inner join, and we will join these two tables in our materialized view using our primary key and foreign key, which is customer ID. So this is how we will join our tables, okay? For this, first we will import all our DLT and then functions and types. Then we are going to create materialized view. So for that, as I have told you, this table we are going to create as it is. This is our table name. We are defining one function with the table name. Here we are using dot read. For the streaming table, we have used read stream. Here we are just going to use read. Okay, so we are just reading two tables separately. First is customers transformed, and then accounts transaction transformed into customers and transaction. We are naming it as TX. And then we are joining it. We are joining customers, join, then we are going to join it to TX. And with on, we will mention our key, which is primary key and foreign key to both of the tables. So this customer ID, this is primary key for this customers table, and then it is foreign key for this accounts and transactions. So that key we need to specify it here using on. and by how you will define which join you would like to have. So as of now, we are going to have inner join, and then we are going to return all of the values which we are getting in this joint. Okay, so this is how we can write our code to join the tables. Now we are going to run our pipeline with the full refresh. Now let's wait till we get the output. So now our run is completed. Let's see what we are getting in this materialized view. So if you see here, we are having inner join and it is giving as expected result by joining these both the tables. Okay, so we have ID, name, DOB, gender, join date. Then we have transaction ID, transaction date, month, direction, account transformation date. So this is how we can join our tables using materialized view. Now we will perform aggregation on this materialized view. So for those aggregations, again we will create new materialized view in which we will pull this information and then we will perform some aggregations. Okay. Now the code for the same would be this one. So here we are performing aggregations. So here you will see we are creating new table. Sorry, we are creating new materialized view. That name would be Gold Coast ACC Trans Aggregation. DLT table, and here we are just using read where we are reading our old materialized view where we have used join. Okay, so after this we are defining this function, and in this function let's say what we are doing. So first we are using group by function. Okay, so with group by we are grouping by customers attributes so that all the transaction per customer will get aggregated in one row. Okay, so for that group by we are using customer ID, name, gender, city, status, income range, segment, age, and tenure days, and then dot aggregation. And now here we are performing our aggregations. So by this we are counting distinct accounts for this customer. Then we are having count of total transactions for that customer. Then with this we are having sum of all credit transaction amounts for that customer. Then we are having sum of all debit transaction amounts for that customer. Again we are having and checking average transaction amount across all the transactions for this customer. Then with this we are checking first transaction date for this customer and then last transaction date for this customer. And lastly, we are checking the count of distinct channels used by this customer. So those channels, it would be either ATM, branch, online, or mobile. So that we are checking it over here. So this is how we can perform aggregations. Okay. So this is just for the practice purpose and for the demo purpose. It is not necessary that these aggregations are important for your analysis. So do these analysis by your own, and let's just check, and whatever the required aggregations you would like to have, those aggregation you imply it over here. Okay, so this is just for the demo purpose, like what kind of transformations or aggregations and how those aggregations we can do it in DLT. So now let's run our pipeline with full table refresh. Now our pipeline has run successfully. So this is how our pipeline looks like. So this is the view which we have created right now for doing some aggregations. So if we check the entries here, then we'll see that for respective customer ID, what's the name, what's the gender of that ID, city, status, range, risk segment, what's the age of that customer, tenure days. Then we have done aggregations of like what's the count of that customer's account. So that it has been given here. Then how many transactions that person has done, what are the total credits of that customer, what are the total debits of that customer, then what's the average transaction amount for that customer, what was the first transaction date, what's the last transaction date, and how many channels that customer has used. So this is how we have done aggregations, and our table looks pretty fine. Now what we will do, so we are done with our DLT pipeline creation, right? So let's revise what we have done till now. So we have uploaded our files to the volume in the Databricks. We have read those particular values, or we have read those files into streaming tables into our DLT. So this one was our landing layer. This one was our bronze layer where we have done cleaning part. This, I don't say this, for this I'll say, okay. So this one was our volume. We read files into respective streaming tables. This one was our landing. This one was our bronze layer where we have cleaned the data. This one was our silver layer where we have done transformations. And this one was our gold layer where we have done aggregations and joining part. So volume is done. This part is done. This one was our DLT. Now what we will do, we will create one dashboard, okay? That would be BI dashboard, which is available in Databricks. So we'll create 2 to 3 charts in this. We are not going to focus that much on dashboard creation, okay? So we will create few charts in that, and then once we are done with that, then we are going to have our workflow where we are going to schedule our tasks. So our first task would be our DLT pipeline. We will connect that task with our second task, which is BI dashboard, and then we are going to schedule this pipeline, and then we will see the outcome, okay? So this, we will do this for first run, then we are going to have second run. For that we will see how these tables are changing, and then for that we are going to check how our SCD type 1 and SCD type 2 tables are behaving and if they are working as expected or not. So this is the rest part which we are going to perform right now, okay? So let's go to this dashboard section. We are going to create new dashboard. So our dashboard name would be DLT bank dashboard, and page would be, let's say, first page. Now here we need to pull our data, okay? Here we have datasets, then catalog, and then this assistance is there. So for this, go to catalog. Our catalog is this one. In that we have this schema. In this schema, let's use these two tables, okay? Add to dashboard. Then which dashboard or which table we have done? Okay, trans aggregation. Then we'll have this materialized view also, okay? Our catalog is this one, schema is this one. We will run it. So here also you can see the output, okay? So this is how we have paged our data from the DLT. Now we will go to our page. We'll see add visualization. We'll click on this add visualization. I'll select the area. Now let's say suppose we will use this aggregated table, or we can use this materialized view too. Let's use bar chart. On the x-axis, I'll have maybe customer ID. Okay, so let's use aggregation table. Bar chart. On the x-axis, I'll have gender. And on y-axis, I'll have customer IDs. And for this, I'll not have sum, I'll have distinct count of these customer IDs. Okay. Then color. Okay. Then label, I'll turn it on. For this, title is fine. Description, I don't need it right now. So the title would be maybe gender by customers by gender. Okay. So this is how we can have our first chart. Let's try to create the second one. In this, I'll have, okay, fine, I'll have bar chart again. X-axis, I'll have total credits. And then on y-axis, I'll check total credits yearly. Okay. So okay, for this, we will use transaction date. Okay. We will check last transactions for this. Okay. So last transactions, we will check yearly last transactions. Okay. Then color, change it accordingly. Labels, you can give it. Title, maybe we'll say total credits by last transaction year. This is just for the demo purpose. You can have another dashboards creation. So right now, let's say as of now, we will have two charts here only because we need to focus on workflows and not the dashboard creation. So for this, first you need to publish your dashboard, okay? Otherwise, it will not show this dashboard under the task in workflows. Let's say publish. You can select email addresses whichever required, or you can just close it out. So this is how we have created dashboard. Now we need to create workflow. So for that, come to this jobs and pipeline, click on this job. Your job name would be, I'll just give this name, job project, and then I'll say workflow. Okay. So this is going to be my workflow name or job name. So here it states that add your first task. So my first task is going to be my DLT pipeline. So this I'll select pipeline. Then I need to give my task name. Okay. So my pipeline name was this one. Workflow 1. Type, it is pipeline. Then we need to select the pipeline. Okay, so this is my pipeline which we need to schedule, DLT bank project pipeline. You can set trigger full refresh on the pipeline if you would like to have. Notifications, I'll set the notification for the complete workflow and not for the specific pipeline. Okay. Retries, you can set how many retries you want. Confirm. Metrics threshold, I don't want to have any, so I'll not select it. Now I'll click on create task. So this has created my task with unique job ID, creator, description, schedule, and triggers. So before doing this, I need to add one more task, which is our dashboard. So I have clicked on add task, and then I need to click on dashboard. So first let's see if yes, our dashboard is DLT bank dashboard. Okay. So first we'll give the name and pipeline, maybe workflow, second task. Type is dashboard. SQL warehouse is going to be serverless. Then it depends on, this is important because this dashboard depends on our this pipeline. Once this pipeline gets succeeded, then only we are going to create our dashboard. So for that, we are going to select run if dependencies all succeeded. That means pipeline needs to be succeeded. Duration threshold, I don't want it. Then notification, I'll set it from here. Retries, I don't want it. So I'll save the task first. So this is my okay, so this is my pipeline or workflow. Schedule and trigger, I can add trigger scheduled or on file arrival or continuous. So whatever whatever trigger you would like to have, you can add that. Okay. So scheduled, you can have advanced schedule at what time. As of now, I'll not schedule anything because I'm going to run this pipeline right now. File arrival is also fine. We can have file arrival for this project too, because we are going to add up new files in this. And continuous, it will keep running. So any schedule or any trigger which you would like to have, you can schedule it from here. I'm going to trigger it right now, so I'm not going to schedule it. Job parameters for this project, we are not having any parameters, so it is of no use for us. We will set the notifications from here. Click on edit notifications, add notification, enter your email address. Then I would like to have notification when my pipeline starts, sorry, workflow starts, once it gets succeeded, and if it fails, then I would like to have it. Click on save. Job updated. Now we are going to trigger it manually. We have these options to run it, to trigger it, scheduled, file arrival, and continuous. But as of now, I'm going to trigger it manually. I'll click on this run now. You can click on this view run, then it will show what is running right now. So it states that right now our pipeline is running, and once it gets succeeded, then our dashboard is going to be executed. So as of now, this is blocked and this is running. Timeline, it shows that how much time it is taking. List, again the same thing, again pipeline and dashboard or whichever task you will be having, those will get listed here. Okay. Now if I'll click on this pipeline, it will show you that our graph is getting prepared, and on the right hand side we will have all the details: job ID, run ID, task. We have launched it manually because we have triggered this pipeline manually and we didn't schedule it. Started at what time? It will show the duration, how much time it takes. Status is running. So now we can see that our graph is prepared, and now it is creating and running our tables one by one. See details. So with see details, it will navigate you to this platform or this jobs and pipeline section, where we can see in depth like what is getting run and how, what are the entries, what are the tables. If you'd like to open that table, then you can select it from here and check the entries. So now our run is completed. Our pipeline run is completed. Now we can see that this pipeline workflow has been done. Now it has navigated to another task, which is workflow 2, which is our dashboard. It is in running status. So it states that it is taking the dashboard snapshot. Dashboard successfully refreshed, and it will give you dashboard link. This link will navigate you to your dashboard, which you published some time ago. Now here in the workflow, this is our workflow which I have triggered. So before recording this, I have triggered this workflow just to check the outputs and how much time it takes. So this is that one, and it is succeeded. That's why it is in green status. So right now for this, if you'll see, first workflow has taken 3 minutes and second one has taken 2 minutes. So before I was working on this, it has taken, for the same pipeline, it has taken around 8 to 10 minutes. So it depends that maximum time it can also take till 8 to 10 minutes. So in that case, you just don't need to panic, because in that situation, I thought that I'm doing something wrong and I kept canceling my pipeline. But afterwards, I got to know that sometimes it might take some time because we are using free edition. That's why this can happen with you also. So you can also take care of this and run the pipeline. Now, what we will do, we will upload some more files into our pipeline, okay? Into our volume, not in the pipeline. So we'll see we have uploaded 2023 data. Now we will upload 2024 data, okay? So we have two sets. For the customer, we have two sets, and for the accounts, we have two sets. So now let's say I would like to check SCD type 1 and 2 also, right? So for that, what we can do, I'll open one customer 2024 set. Then I'll add some 2023 data with some modified columns here, and we'll check then if it is working or not. Customer set 1. So let's upload these 10 entries into our 2024 dataset here, and then we need to modify something, right? For this, let's say suppose for this I'll have this ATM everywhere. I'll change everything to ATM. Then maybe I'll say all these are teachers. Teacher. Okay, so I have done some changes into customers for customer ID 1 to 10. Now let's upload these files to our volume. So this is my volume. Customers, upload to this volume. Browse. Twenty 2024 dataset we are left with. Open this, upload. Now coming back to our accounts folder, here also we will upload our 2024 data. 2024 set 1 and set 2. Upload. Before this, what we will do, we will have select star from on our SCD1 and SCD2 tables, okay? Select star from. This is my SCD1 table. We'll run it, and then again we will have select star from. This is the data which we got, and then select star from this SCD2, and this is the data set which we have right now, okay? Let's see now if our SCD1 and 2 functions properly or not. So for this, we have uploaded our data into volume. We have checked our entries. Now we need to run our pipeline again. So jobs and pipeline. This is my pipeline. Not jobs and pipeline. I need to go to jobs. DLT bank project workflow. So this is my task. Now again I'm going to run it and trigger this pipeline and dashboard manually. So this workflow I'm going to trigger it manually. So run now. We can see the run. Now our pipeline is succeeded. Let's come back and see what's happening. Now we can see that it is preparing for the dashboard. Now our dashboard is running. We'll click on this. So our dashboard is refreshed successfully. Click on this. This is how my updated dashboard looks like. We need to check if our SCD1 and 2 is working or not. So I'll just open that file where we have added the entries. So these are the entries which we have added and changed. Now I'll create one cell down this, and then we are going to have select star from. We'll see here our customer IDs were from 1 to 10. Okay, but okay, we have few entries here because we were having null values and everything, so it must have gotten changed. We'll see here now our preferred channel and occupation. We have changed these two values, right? So it has gotten replaced as expected, but we don't have any kind of history stored here. Okay, so this is how this SCD1 functions. Now we are going to upload one more file into accounts folder so that we will be able to get to know that if this SCD2 is working properly or not. So to check this, what we will do, first we will check what are the entries which we are having for this account ID 1000010. So after this execution, we know that for this account ID we have two entries with account type current, balance is there, and we have rest of the values with end date is null. So for this, what we will do, now we have this, I have created one more file for this. In that I have given both of these values for account ID 1000010, and here I'm going to change balance and tax amount. Okay, so let's say suppose balance I'll give 20 and 30, tax amount I'll give, sorry, transaction amount I'll give 200 and 300. I'll close this file, and we are going to upload this file into this folder in the volume. So we will say upload to this volume, browse, open. Now we have uploaded our file. Okay, coming back to our pipeline, so we can run workflow for this, and we can run our DLT pipeline standalone too. Okay, so for this, what I'll do, I'll run this pipeline standalone. So for this, I'll just click on this run pipeline. Now let's see what are the values which we will get. In this, we are hoping that the new file which we have given, that file needs to be read with the streaming table, and that data will get processed going forward. So let's wait till this pipeline gets completed. Now here we can see that output records 2 because we have added two values into our new file, and that file has been uploaded in our volume. So it is expected that being this streaming table, this streaming table needs to read only new values. So as expected, it has read two values. For customers, we are not having any new values, so these records are, it didn't read any kind of new record here. Account, now we can see that absorted values, we can see it here, and those are 4. If we'll come down, if we'll see here for that SCD2 table, here it shows that it has absorted values and the count is 4. Now we will see it here, okay? So this select query I ran initially before running the pipeline. At that time, for this account ID 1000010, the entries, we were having only 2 entries, and we have modified these entries, right? Now, after running pipeline, we will see what's the result which we are getting for this account ID. We are expecting 4 values here. Okay, this is as expected because we have updated both of the values, right? You will see this value we have updated with 300 and this value we have updated with 200. And similarly, balance also we updated to 500 and 700. And for this, for the old entry, we'll see it has updated this end at date and it has created new value with new start date, and for this end at is null. That means that this entry is active right now. Similarly, for the second entry, we can see that this entry is now active, and the previous entry or the previous history for this, it has been updated with end at date. So this is how this SCD type 2 functions. Before concluding our tutorial, I would like to show you one more thing which I forgot earlier. So when we created workflow and when we ran our workflow, at that time we set the notifications, right, for our respective email address. That I forgot to show you. So I'll show you right now. So when we ran our pipeline, at that time this email got triggered, and when I finished the pipeline with success, then this mail got triggered, okay? So if I'll open this mail, then we can see that we got this mail from Databricks, and it says that initiated a run for this job, and we got some run details for the same. So if you'll navigate to this, then it will navigate you to that respective workflow page, and with this you can open your Databricks too. So this is how we can get an email for the initiation, and similarly we will get the email once our file gets succeeded, okay? So this is the message which we get after success. In this we will see status is succeeded, and it will state that a run of this job is completed successfully. So this is how we get the emails. Here we come at the end of our tutorial. So this is how we executed our project. To revise it quickly, using data ingestion, we have ingested our data into our volumes. So we have used multiple files, CSV files, to store our data into the volumes. Then once we had our data into volumes, afterwards we created this DLT pipeline. So in this pipeline we have ingested this data. After data ingestion, we have seen how we can create streaming table, materialized views, temporary views, then how we can apply quality checks. Afterwards, we have seen how we can perform data cleaning, then how we can perform data transformation, how we can perform data aggregation, then how we can apply SCD types, SCD type 1 and 2. So this is how we have seen DLT pipeline creation. In that, we have followed our medallion architecture using bronze, silver, and gold layer, in which we have done data ingestion in bronze layer, then data cleaning in silver layer, and data business aggregations in the gold layer. So once our pipeline was ready, then we have created BI dashboard, in which we have fetched the tables which we have created in this DLT pipeline. So this DLT pipeline we have created here, and once this pipeline was ready, we have created dashboards. We have created one dashboard. In that, we had the values from this business aggregation layer, and afterwards, once this BI dashboard was ready, we have created jobs. So this job is nothing but we have created workflow. So in that workflow, we have we had two tasks. One is this DLT, and then another one was this BI dashboard. So this is the workflow which we have created, and then we have connected our DLT with BI dashboard, and then we triggered our workflow, and afterwards we saw how our tables got updated. So after first run, we have run our pipeline for the second time for the newly added file which we uploaded into volume, and after that we again ran our file for again newly updated values, and afterwards we have seen how SCD1 and SCD2 functions, and based on that how our BI dashboard gets updated, and how our all streaming tables, or all the tables, whether it could be streaming table, materialized view, how those tables or views get updated, and what are the values which we get afterwards. So this is how we created this Lakeflow declarative pipeline, automated Lakeflow declarative pipeline. So if you have liked my video, please like and subscribe to my channel. And going forward in the next project, I'm trying to create again automated pipeline with SQL, because this project we have followed Python language. Next project I'm going to use SQL language, and then we are going to create our automated Lakeflow declarative pipeline. So if you have liked my video, please like and subscribe, and see you in the next video. Till then, keep crunching the data.